Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive.
Hello, contributors, mentors, and many other people that help the Liquid Galaxy community on this Google Summer of Code 2025. So today is demo day, and what's the demo day for the Liquid Galaxy at the Google Summer of Code project? So demo day is the day that all the contributors have to show up. What has been their developments during the summer? We are still something like 5 days till the end of GSoC, but they have to show up everything, and they just have a few days to end the documentation and still repair some bugs and so on. But the very important thing is that we have, oh, take a look at this. We have a robot arm behind us working on Chromius. This is the application made by Devanjan, contributor Devanjan, very nice, with mentor Victor and mentor Moises. The robotic simulation, we have 3 different projects this year on robotics, very nice ones. And I'm reading my false teleprompter behind the camera. So today is the day where the 11 contributors will be showing their projects and also commenting their personal experiences. And next to this, we will have everyone's mentor explaining their thoughts, how this year program has gone, and how's been the development of their mentee. And to make some accounting, this year we have something like, of course, 11 contributors finally, because one contributor have a problem, health problem, and he discarded from GSoC at the very beginning. We have a large mentor team of 20 persons, and also we have 20 more persons helping us on the many tasks we have next to the code development, that it's doing testing, doing documentation, recording many videos we do, and many other stuff we have to do here at the Liquid Galaxy lab in Lleida, headquarters of the Liquid Galaxy project. And also I'm happy to say that this year we are a very diverse community. We have people from 10 countries working with us in this Summer of Code, and 20% of them are women in both contributors and mentors teams. So that's very nice for us. Let me go also. One of the many phrases I pronounce all year long when we are trying to reach GSoC is that GSoC takes a lot to arrive, but suddenly it goes so fast, because summer in 3 months is nothing of them, since the contributors are announced in June till the end of August passes so fast. And then that's only the cuspid of the pyramid, because we work all year long on the Liquid Galaxy project with our more than 1,000 people interested that we have on our Discord, and many other hundreds hanging around. And also we have the different laboratories around the world. And also I'm very happy to announce that this year we are going to expand our laboratories network. We are going to open 2 new laboratories in India by the hard work of the mentor Jash Raj, that now he's become a Google developer expert in web, and mentor Vedan. They make an effort in the past months with their own universities, very important universities in India, to have new laboratories, new Liquid Galaxy laboratories that will help local students to also do what students do in Lleida and other places of the world, that is having the opportunity of have a real Liquid Galaxy system to test their applications and to know about our technology and tech stack. So here we are at Liquid Galaxy Lab Lleida, headquarters of the Liquid Galaxy project. We have several instances of the Liquid Galaxies. You can see here our 3 screens, one of the many 3 screens. We have 3, 5, and the big one, the Lleida Liquid Galaxy. What I wanted to tell you is other questions regarding the project. Oops, let's go to the world, not to Spain, to the world. This is the world. So the point is that many of the contributors that are selected for the Google Summer of Code or come to the laboratories, different laboratories we have, they are being introduced to many different Google technologies and others. We are very good at doing stuff with Flutter. It's our main tech stack for the development of the user interface and most of the base of the application. This year also we have something like a Docker server specific to handle the most complicated applications, like the robotics ones, the 3 robotics ones we have. And we also work this year, we have finally using the web server new paradigm for the Liquid Galaxy, that still, instead of working with Flutter or with all scripting languages that we haven't not done for many years, like Python and so on. This year also, and developed by Mentor Josh, we have the Liquid Galaxy web server, and there was one contributor, Anishka, from India, that developed the very first application for the GSoC using web technologies, very nice one. Also, I'm happy to say that we are not alone on the Liquid Galaxy project. We have a very tight proximity next to the Google Developers Group Lleida, and many of our colleagues from the Google Developers Group Spain. We have plenty of Google developer experts, our colleague Victor Sanchez, Moises Martinez, Alfredo Bautista, and some others. And of course, we have also a tight proximity with Women Touchmakers Lleida, and because I'm also happy to say that we are 4 different Women Touchmakers ambassadors that collaborate with the Liquid Galaxy project on the Google Summer of Code and other projects we do all year long. Not too much from my side today. We're going to see, after my introduction, the 11 contributors demo day videos. But before end, of course, I want to say thank you to all the special contributors to the project. Mentor Claudia, that is next to me on the administration. Mentor Jazz, that this year also helped at administration. And also the very huge team. I have to look at the sign we have here, because we have plenty of Mentor Claudia, Mentor Irene, Alba, Rosemarie, Mahinur, with the help of Paula and Lila. And also then we have Mentor Jazz, Vedan, Gabri, Miquel, Alfredo, Victor Carreras, Victor Sanchez, Prayak, Siddharth, Mentor Oscar from Tenerife, Mentor Victor Perez. We have 3 Victors, not 1, from Barcelona, Mentor Mario from La Rioja, Mentor Moises Martinez, very good friend of us, me as administrator with my other colleagues, as I say, and then we have plenty of 20 more persons helping us. So thank you all for collaborating this year with us. And let me take a look at my notes. I think that's all. So thank you for listening, and let's see the videos of this year Google Summer of Code 2025 at the Liquid Galaxy project.
Hello everyone, my name is Shubham Swapnil Dash. I am from Bhubaneswar, Odisha, India. I am currently a pre-final undergraduate student who is pursuing Integrated Master of Technology in Mathematics and Computing at Indian Institute of Technology, Indian School of Mines, Dhanbad. In the Google Summer of Code 2025, I am working with our organization, Liquid Galaxy, on the project named Eco Explorer for Liquid Galaxy. So, what is Eco Explorer for Liquid Galaxy? It is a project that aims to create a geospatial dashboard visualization of the various expansive and large forests around the world. It has several features like AI generated tour itinerary guide with text to speech inference, graphical 3D visualization of the biodiversity using 3D models, joystick controlled rig controller that enables a fun user experience controlling our Liquid Galaxy rig, and other features like catastrophe visualization, forest fires, and graphical visualization of the environmental status of the forests.
So let's jump to the coding and the application part. I will start my explanation with my home page, which consists of a list of all the forests which I will be visualizing in our Liquid Galaxy rig. The home screen consists of a bottom navigation bar, which takes us to various pages like the start screen, the API authentication screen, the preferences screen, and the about screen. First of all, let's talk about the start screen. The start screen contains all the forests, or the list of the forests, which is loaded using the list view, and the UI widget, which represents the data of each individual forest, is a neumorphic UI. Also, to enhance the user experience, I have included the help screen, in which I have the instructions regarding how to obtain the API keys for free. Next, I have the settings screen, in which I have executed all the SSH commands. And in order to connect to our rig, I use the usual SSH command, which connects us to the SSH rig. As you can see here, it initializes the SSH client and connects to the socket. In addition to that, I have the LG commands like set select refresh, reset select refresh, relaunch, and reboot, which are also a couple of LG commands that have been utilized or been applied using our SSH interface by passing it to the terminal of our Ubuntu server. In addition to that, my preferences screen also includes a button to download the 3D data. So to display the biodiversity, I have used the 3D Blender KMZs, which are quite high in size, around 75 MBs. So in order to download this data, I have included a data downloader in which I can access my GitHub repository using this URL and then download it using a package called Flutter Downloader. And it saves it to the local path or the application document directory, which you can see here. Also, to ensure flexibility to the maximum extent, I have included the delete 3D data option, which you can see in the top right, which deletes the data from the application document directory. Let's jump to the functionality of the dashboard. So when I open an individual forest, it opens up a map view. The map view takes the data from my JSON file. So this is the forest.json file in which I have included all that. I have scraped many websites, Wikipedia data, and created a JSON file for each forest, displaying its latitude and longitude. So what the map does is the map view takes latitude and longitude as the input and shows the particular place in my mobile application as well as the rig. With the LG rig is also synchronized to this by using my SSH function, in which when camera is moved, the map position changes, and finally it flies to the position when my map is stopped. It takes the input from the target, the zoom, the tilt, and the bearing, and flies to that particular location. My first window is the information window, which includes all the geographical details, and then I have to take a tour button. This tour button is powered by the Grok API and the DeepGram API. What the Grok API does is it creates a JSON file of this format, showing the latitude, longitude, name, and description of the various locations that we want to tour around the forest. It uses the Gemma 2 with the 9 billion parameter model. I have set a prompt for this, to which it provides the response as. Now I will switch off the voice because DeepGram, it will be better to display when I'm showing my demo in the rig, in the DeepGram. So let me start the tour first. Yeah, so this is the carousel slider, which is formed right here in the tour viewer. I have created this carousel slider, which decodes our JSON and creates a list view with this. Along with this, I have a start tour button in the bottom right, which will start a tour with this orbit controller. So it flies to locations and then orbits around each individual of the 5 locations mentioned here. It tours around them individually and orbits around them in a constant loop while speaking using my tour guide of DeepGram. Next up, I have the map switch button, in which has a satellite, terrain, and hybrid. For this, I will switch to my dashboard screen. Here I have the toggle buttons widget, in which I have used the list view to toggle around this using a variable known as a map index provider, and I have modified my colors according to that. And then here I have the biodiversity window. In the biodiversity window, I have a grid view like this, a grid view in which I have a theme card. I have applied my theme card as individual element. Upon clicking this, here I have not downloaded the 3D data, which I have already explained. So there is again the shared reference boolean, which is downloaded. If it is now it is set to false. Once I hit yes on this, it downloads the data. Then I'm again visible to send the KMZ file using my normal SSH send commands. So let me display you the commands. The KML file is uploaded using our SFTP client, in which we can create, truncate, and write. And then finally, I can send the KML using my usual send KML command, which you can see here. I have also put a couple of error handling options to this, like the SSH channel open error and SSH dead error, in order to enhance the user experience. In case any of this happens, it automatically gets disconnected, it automatically disconnects itself from the SSH server and then reconnects automatically. After this, I have the environmental data display, in which I'll be showing the air quality index. So this is the pyramid visualization, which for which I have used the SyncFusion flutter charts. This is the SF pyramid chart, which has a battery-like representation. Like if it is good, all the five columns are filled. If and now, as you can see, it is where that's a 4 or 5 are filled. And again, if it's very poor, it reaches the lowest level, showing a red color. And again, I have this concentrations level, in which I am using a simple gradient gradient bar to show the level of the concentration, and according to this, the danger level is shown. And to display the historical data, I am using my API, or the Open Weather API, which I'll display here. So this is the provider. Historical data is recovered from here, and then it is sent to the repository, in which I have used the RiverPod architecture. In the AQI repository, once it is there sent, first of all, we check if it is connected to the internet. So internet connection is checked, whether it is connected to any Wi-Fi or LAN or maybe the mobile data. Again, if it is connected, then the API is fetched correctly, and the error handling is done in case the API is invalid or it is not able to fetch the data. But in case it is offline, I have also included the database provider to cache my data. For this, I have used my Hive database. There is this model called AQI model, which I have included as the Hive type, and generated the code so that it is cached locally and can be recovered even if when network is not available, or in case if the API is deprecated due to some reason. And when I click on this button of visualize data, what it does is, let me show you. I'll go to the environment screen. It takes a screenshot. It takes a screenshot, stores the screenshot of these 3 widgets locally in my file, then creates a UI until list decoded image out of this, which is also uploaded using the SFTP command. But here, as you have noticed, I have used a .png format. And finally, it uses the STP to transfer this from the master server to the slave rig, and shows the data in the form of a balloon. Let me show you the KML of the balloon also. So I'll go to the balloon entity, and this is my AQI balloon, in which I am using the local file source. I'm fetching my local file source with a fixed ratio to display my data as a part of the environmental data graphical visual display. Next, I have the catastrophe window, in which there are 2 parts. The first part is the recent forest fires. So what the recent forest fires does is, it uses the NASA Forms API. Yes, it follows the same RiverPod architecture as my Open Weather API, so I'm not going to explain that. But there is a catch. When I'm recovering my data from the Open Weather API, it uses a JSON formatted file, but here I have used the CSV file. In order to decode CSV, I implement a different strategy. I use the CSV to list converter and then pass it accordingly to the required data, like latitude, longitude, TI4 brightness, TI5 brightness, and whether it is day or night. All the fires, then when it is fetched to my catastrophe, to my front end, then it is filtered to all my data fetched from the repository is filtered in my notifier file. It is actually filtered according to the countries. So there are multiple countries into which the forests belong. So I also need to filter a latitude and longitude range, which also I have provided in my JSON data. Like this is the min lat, max lat, min lon, and min long. In this box of area, all the fires will be filtered in my front end, in my catastrophe street, and then according to this, it is sent to another map view, which will be which will be displayed as a set of individual points. To display the KML code related to this, I create a fire place mark of each of the individual style. I take the TI5 and TI4 brightness as the parameters to determine whether it is of high magnitude, medium magnitude, and low magnitude. Accordingly, I assign style to this, and then I create the KML so that a cluster of points are shown on the rig with their respective colors or the icons related to them. Like for the high, it is a reddish color. For medium, it is orange color glow, and low, it is a yellowish color, small size glow. Next up, I have the deforestation time lapse, in which I am using a time lapse feature. So how I am using the time lapse feature? It can be controlled by our simple touch commands. There are 5 elements to this: 2003, 2008, 2013, 2018, and 2023. This data has been filtered from the ecoregions, our world in database, and stored locally, by which I determine the magnitude of deforestation in each forest, which is also divided into several sub-regions. If I take the slider to suppose 2018, It calls my data, filter calls my data, and sees what was the magnitude of the deforestation in this particular year of this particular forest, and then sends my KML, which I'll be showing right now. So this is my deforestation KML. This is a simple multi-geometry polygon, which will be displaying the borders of the forest, and then according to that, it will be assigning a style 1 or style 2, ranging to style 5 according to magnitude of deforestation that has been shown. Again, the magnitude of the deforestation has been shown in another JSON file, that is the deforestation.json. So, and then another feature that I have included as an extra is my joystick rig controller. So once I click on this visualize data, it opens a joystick-like interface which provides a fun user interface to control the Liquid Galaxy rig. By when I move it up, the rig moves up. When I move it down, it moves down, and so as left and right. And if I let me show you the code that is related to this. There is a joystick button or the controller button, in which I change the latitude and longitude and apply it to the new position according to the magnitude of the movement that the user does.
So let me show you a short demo of the working of my application using my own Liquid Galaxy rig. I have already updated my API keys and connected to the rig. So first of all, I will go to the Mongolian rainforest. Let's try this. First of all, I'll take a tour, turn on my voice, story mode, and start. When I play the tour, it will take to the particular locations with the voice.
Logo National Park. Our journey begins in Logo National Park, a true gem of the Mongolian rainforest. This UNESCO World Heritage Site boasts a remarkable diversity of wildlife, from the majestic forest elephants to the elusive gorillas. Imagine walking through lush, ancient forests. They are thick with the scent of damp earth and exotic blooms. Listen closely as you might hear.
So this is how it works. It will orbit around every individual location, and then I will show you an individual orbit around the forest. So play button. Started an orbit around the forest, and as you can see, there is the balloon, the forest data. Stop it here. Next up, I'll go to the biodiversity. I will click on the elephant. So it will show me a model of 3D model of the elephant. You can see here. Also, I can use my rig controller to move from here. And again, if I want, I can also zoom in. So, and again, I can also change the tilt and heading of the location. Next up, I have the environmental data display. I click on visualize data. It takes me to, it flies to the top of the forest, and it will show the screenshot on the right side of the screen. As you can see, in the control is visible. It took the screenshot of the whole thing and showed it here in my rig. Then the next thing is the deforestation time lapse. Deforestation time lapse here in 2003, it shows the light. I have shown the clear demarcation of what the color indicates. So here, in the year 2003, the loss was between 10,000 and 100,000 hectares in this region. So that's why it is colored in light green. Let me zoom out to show how it is divided into the eastern and the western region. So this is the eastern region in which the deforestation was slightly lower, and again there is the eastern region where it is slightly higher. That's why it is yellow colored. It was between maybe 1,000 to 100,000 hectares to 500,000 hectares. And as I slide it to 2013, maybe, yeah, in the year 2013, the parameters are a little different. It has improved, and it has worsened in the case of deforestation. And here it is colored yellow, and the western part is colored orange, as you can see. Talking about my experience of Google Summer of Code 2025, first of all, I would like to express my heartfelt gratitude to my mentors, Gabriel sir and Alfredo sir, who helped me in each step of the project. As it was rightly said by Andrew sir, GSoC arrives slowly, but once it arrives, it proceeds very fast. Few months ago, I was new to open source contribution, but the well-documented Liquid Galaxy projects of the past years helped me largely frame my code, my application, and even the execution in the rig. So I took inspiration from many of the previous projects while working on my code. I had done few of my research works in the community bonding period, which helped me a lot for finishing the project in time. My project was mainly divided into three parts. The first was the user experience or the application part. Alfredo sir helped a lot in this. He suggested and explained the riverpod architecture to me, which helped me put forward several aspects of the application for its optimal performance and its great user experience, along with the features of synchronization with our rig. Then the next part was working with the KMLs. There were several KML visualization options that I had already installed while working on my proposal. So my task was just to create the accurate template and execute it successfully by integrating to the various APIs like the NASA Forms API or the Open Weather API that I am fetching. And then the last and the most important part was to execute the commands using SSH. There were a few commands which were already been worked out during my prerequisite tasks before the GSoC period. But there are also several other functions that were not working. But Gabriel sir helped me out with hours of meetings and then explanations from the codes for many features like the orbit, or maybe let's talk about the image overlay, which I took the screenshot and uploaded it as a local file. It Without Gabriel sir, it would have been impossible to execute. And finally, I would provide my sincere thanks to Andrew sir and Yash sir for giving me this opportunity to work in the Liquid Galaxy organization in this prestigious project. And a special thanks to the testing team for pointing out my flaws and making this application a finished product. So that's it for my demo day video. Thank you very much.
Hello everybody, I'm Gabriel and I'm the main mentor for the Eco Explorer for Liquid Galaxy project. First of all, I would like to congratulate Shubham on his work. I'm aware that he has put a lot of effort and many hours into the project, and this is evident in the result. Shubham had a clear idea of the application he wanted to create from the beginning, and this was evident in the project proposal, as there was not much difference between what was proposed and what was presented. So this made it very easy to guide him through the weeks, because he knew what he had to do at each step. So my experience as a mentor this year has been most rewarding. See, as mentors, it's very satisfying to see that your support, advice and guidance towards the contributors are accepted and applied, and I can confirm that this has been the case with Shubham. I'm very pleased to have been his mentor and with the outcome of the project. And of course, I would like to congratulate Andreu for another successful year.
Hello everyone, my name is Alfredo Bautista, Flutter and Dart GDE, and I want to share in this video with you my experience in the second year as a mentor in the Liquid Galaxy in the Google Summer of Code. First of all, I want to start from the beginning. So when Shubham was my mentoree, we collaborate together during these weeks to design, prototype and choose the best solution to our Flutter app. So Shubham designed a Flutter app that used the Liquid Galaxy ring to show more information to the end user. So the proposal was very nice. So we collaborate together every week to solve all the issues building a Flutter app. So we need to choose a Flutter state management solution. We need to choose some package for the communication. We need to choose or decide some UI solution. And we collaborate a lot during these weeks to build the final product that you can check in the Liquid Galaxy store. So as a wrap of all of this week, I only want to share that it's amazing collaborate with motivate people that very like the technology. So if you didn't apply to the Google Summer of Code, I recommend you to do in the next year, because it is an amazing experience. To wrap up or to finish the video, also I want to say thank you to Andreu. Also I want to gratitude all the effort that put Andreu every summer in the Liquid Galaxy project, in every Google Summer of Code for these long years. So it is amazing. Thank you, Andreu, for all of your effort, all of your work in this project. And if you didn't check all the projects that we have in the Liquid Galaxy project, check online, because you will find a lot of nice apps and projects around the Liquid Galaxy. So see you soon. I hope to see you in 2026, and take care.
welcome to Amazon Rainforest. Meeting of the Waters. Our journey begins at the meeting of the waters, where the mighty Rio Negro, black as night, flows alongside the Amazon River, a muddy brown torrent. This confluence creates a mesmerizing spectacle, a natural dividing line where two distinct waters meet yet refuse to blend for miles. Imagine the ancient stories whispered by the river banks. Longo National Park. Welcome to Longo National Park, a true gem of the Cambodian rainforest. This vast protected area is home to an incredible diversity of wildlife, including gorillas, horses, elephants, chimpanzees, and a plethora of colorful birds. The park has rainforests for teeming with life, and its pristine beaches offer a glimpse into the beauty of the Atlantic coast. Here you can witness on
Hello, I am Mohit and I am from Rajasthan in India. And currently I am pursuing my undergraduate from National Institute of Technology, Rourkela. Currently I am a third year student here at NIT Rourkela, and the project that I am doing in this GSoC is Martian climate dashboard. So I'll be showing around my code now, what I did in last around 2 months. So this is main structure of the code. So here there are basic file folders which are present inside the lib directory of my app. So I'll collapse this, and this is the lib directory that is present. There are these folders which are present, and I'll get to them one by one. There are 6 folders, sorry, not 5. So the first one is entities. So there are 4 entities that I am using in my app. There's API entity, for which I am creating a class for before calling the API, that is Martian climate database. So before calling that, I have made this API which will automatically give me the URL that needs to be called, and then it will After fetching all the data would be given by this. And then there's balloon entity. The balloon entity would be used to make balloon as it says. So it will have. Let me show you entities. Balloon entity. So it will have this type, color map, and API entity. So it takes an API entity to generate this balloon. For a grid, we have a simple grid for creating interpolation of data because the data that I'm getting is very less, so I need to interpolate this, and to interpolate that I need to make a grid for that. So that's why I have this grid entity. And for saving all the sessions, I am using this session entity, which is essentially saving the API entity and the image that is being generated while showing the visualization. So next is service. So here I have another folder called services. There are these files that are present in services. So I'll go by them one by one. So what API service is doing is extending what is API entity was doing. So API entity was simply an object, but API service extends it and gives more functions or more methods which could be called upon API services. Balloon service is same as extending as API entity, and it gives more functions and it performs the main logic of creating the balloon. KML services is just interpolating and generating the KML from less data. I'm averaging out the data and interpolating all the data and then creating a bigger KML. Tour service, as it says, generates the tour. And LG service is the service that take care of all the LG command that needs to be taken off, like checking connection and setting refresh, setting reset, reboot, and all that. So this was all about the service folder. For enums, I have 3 folders. Enums, in enum folder, I have first one is balloon type. So there could be 2 types of balloon. The first is the normal visualization balloon that is shown every time a visualization is created. And it shows everything like the summary and the scale that shows the gradient of what each color signifies. And there's this another type of balloon that is shown when the AI goes to some place, like if I ask AI where is this place, and then it will go there and it will give a different balloon telling about that place. So to save this, I have 2 types of balloon. I'll show you that. Enums balloon type, there's this info and there's this summary. Other one is color map. So there's this color map. There are various color maps that could be shown on Liquid Galaxy and also the database. So I am when interpolating, I'm also giving different colors to the different values. So this is the value, then this is the color that will be given. There's this enum. These are the color maps that are supported. The next one is role. So this role is for while chatting with AI to know which message box to go in which direction. I'm using this role enum, so it will have nothing but user or model. So this was all about enums. I'll get to pages later on. So I have these utils. So in utils I have routes. Routes are I'll show you the routes. So here I have routes. So these are the routes. It is like pages where I need to navigate to. So I don't need to give holes of this class to navigate to somewhere. I could simply give this route and it will navigate there. And then I have theme data. So I have all the theme colors that sorry. So I have all the theme colors that I need. So here I'll go to theme data. Here there are all the colors that I'm using. The next is parameter maps. So the database requires a lot of so database does not takes in temperature as its parameters. It takes T for pressure, it takes P for density, it takes rho, and for different parameter it takes different key letter or word. So to map these, I have generated this map in utils folder. The next is button, the widgets. So these are the basic widgets that I have used throughout this app. First one is button. So I'll show this. This is the button app, button widget. This is the checkbox widget. Is this one. Date picker is this one. Yeah. Globe projection is this one. So I am creating this projection using a single image, a 2D image. I am creating this something like convex lens type of projection. So this is done by this widget. Date pick I already told. Loading indicator is there in visualization page. There's this drawer that is present. This is a drawer, and this card is also there. This is the card. Yeah. So the last folder that is left is this home page. Sorry, pages. So the first one is home page. So home page is nothing but this one. This page is home page. Visualization page is when visualize data is clicked and user is navigated to the AI page. That page is visualization page. This is the connection page that is there. This is the QR page that is present. Also the API key page, which where the user needs to enter his API key. There's about page that is present here, and there's also a tools page where every LG tool is present. So here are all the where it is. Yeah, here are all the pages that are present, and yeah, that was about my code. So I'll be giving my a quick demo of my app. So here I have my app running. I'll quickly restart my app. So as soon as this will restart, it will automatically switch to Mars. So first this splash screen will show, and then this switching to Mars will happen. Now it has switched to Mars. Now there are three quick visualizations that are present here. So there's temperature, there's pressure, and there's density. It is all these are for today. So I'll run temperature, and this will generate the KML. It will fetch the KML, and it will generate balloons and all those things. It will give me the logo and the balloon. It will take some time to do that, and this is the Mars that is showing on Liquid Galaxy, Virtual Liquid Galaxy. It is about 96% done. Yes. So this is the finished visualization that is there. It is generating summary right now. So as soon as this summary is generated, this balloon will show up. This is the balloon that is showing the minimum, the maximum, and the summary of this visualization. So I could ask more question to this AI. For example, if I ask where is Olympus Mons? Olympus Mons, it should tell me where it is. Yes, so it is now showing me the location of Olympus Mons, and it is also showing me this balloon telling about Olympus Mons. So I could also ask it different types of question about this visualization. For example, if I ask it tell me more about this visualization, so it should tell me. Now it is thinking, and it will tell me if there's anything extra to this visualization or any insights to this visualization. So these are the extra things that are there about this visualization that the AI has told me. So other than this, I have connection page where the user must connect before entering the app or before running the visualization. There's this API key which is important to generate the AI response, and when you click this I button, it takes you to the page where API key could be generated and it could be entered here. There's also this tools page which could be used to control Liquid Galaxy. For example, if I do relaunch LG and click yes, it should relaunch here. And I have about page also where there's information about the app. So other than these feature, I have this date range feature which is also present. So I'll choose pressure this time, and I'll add first date to be 1st of August and second date to be 5th of August. and then I'll just fix this. And then if I click visualization, this should create visualization. So it has changed to mass automatically without doing anything manually. Now the visualization is done, and it is showing up on the Liquid Galaxy rig. It is also showing this balloon, and if I go to next date, it will generate visualization for the next date, and I can do this till the date that I have selected for in the date range feature. So this is the updated visualization for the next day, and this also I could start orbit and stop orbit, so I could orbit around this visualization like this, and to stop orbit I simply need to click this stop orbit option here, and it will stop. So this was there's also this section where recently visualized is written. So here all the visualization that I have previously visualized will get stored, and it is limited to 5 visualizations. So last 5 visualizations will show here. Personal experience has been amazing throughout the GSoC period. I learned a lot of new things like writing tests and documenting my code. I also learned how to stay consistent for long-term projects. Mentor Victor has been a great help throughout my project. He helped me a lot for debugging, and he also gave me a lot of flexibility and a lot of freedom to try new things. Admin Andrew also helped me, and he also pushed me to achieve more in my project. I also learned communication skills, and I also learned self-belief because of this project. And I would like to thank Liquid Galaxy Lab and Liquid Galaxy Project for giving me this opportunity to work on this project. Thank you.
Hello everyone! Every year being in the Google Summer of Code inside of Liquid Galaxy makes me develop a new soft skill to improve my own way. But this year, Liquid Galaxy exceeded all my expectations. I had to develop different soft skills. Also, I did a strong relationship with my mentee, and that helps him for create a new way to get his goals, and that makes me also more closer for PRs, for different other better skills that help him more in other things more than only develop. Also this year we had AI, a lot of AI everywhere, and that that makes me a perspective way to use AI in completely new environments, because Mars project was something that the beginning was really great, looks really great, sounds really great, because it's more physical, more, you know, astronomy, things related, and seeing how Gemini can help us is awesome.
Hello everyone, I'm Marc Bañeres Ferran, and I'm from Lleida, Spain. This is my demo day video for GSoC 2025. During this year, I have studied at Lleida's eLearn Center. My project for GSoC 2025 is an app called Data Spaces Visualization for Liquid Galaxy. This app displays and sends data from 5 data spaces. Specifically, the app displays real-time data about buses in Málaga, environmental sensors in Santander, and pig farms in Lleida. Now, I'm gonna show you the app's code. First of all, I have to say that the Google Maps wiki goes here, on the strings.xml file. Now, let's see the rest of the project. I have my app organized in folders. As you can see here, there are the models, pages, providers, the services, the theme, and the widgets. Let's see the models, specifically the KML models. This is the model of the blank KML. This is the model of the balloon of the buses. This is the model for the KML of the buses. This is the model for the trail of the buses. This is the model for the synchronization of the app's map and the Liquid Galaxy. This is the model for the balloon of the big farms. This is the model for the KML of the big farms. This is the model for the logos. This is the model for the balloons of the sensors. And this is the model for the KML of the sensors. Now let's see the rest of the models. This is the model for the firmware bus locations. This is the model for the bus locations in general. This is the model for the LG collection to connect the app to Liquid Galaxy. This is the model for the pig farm location. This is the model for the sensor location from firmware. And this is the model for the sensor locations in general. There is a second file for sensors because there are different types of sensors. Now, let's see the pages. Here you can see the help page where the user can fill information about the app and everything the app can do. This is the home page where everything of the app is displayed. Here the user can select the buses, the sensors, and the pig farms, and use all the functions of the app. This is the QR scanner page. With this page, the user can scan the QR and get all the Liquid Galaxy data. This is the setting page, where the user can access the QR scanner or put directly the Liquid Galaxy data to place the connection. Also, there are the different types of options, like the Liquid Galaxy services to shut down, reboot, power off, etc. Apart from this, there are also different options like turn on the dark mode of the Google Maps or set different types of data visualization for the buses. Also, here you can turn on the colorblind mode of the app. This is a splash screen the screen that shows the logos of the app while the app is starting. Now let's see providers. This is the visualization provider. This provider controls different types of things of the app, like for example, if the colorblind mode is turned on or off. Now let's see the services. This is the bus access service, which is used for the trail of the buses and also different types of information of the buses. This is the EMT API service. This is the file for the API of the buses. It uses both APIs, the firewall one and the other one. This is the LG service, where you can find all the functions for the Liquid Galaxy. This is the Big Farm service, which controls all the information about the big farms. This is the Santander API service. This service is for the Santander environmental sensors. And this other file is the sensor cache service that is used to cache some different types of information about the sensors. Now, let's see a theme. This is the app theme, where all the colors of the app are declared. We have the base theme and also the colorblind theme. Now, let's see the widgets. This is the bus filter panel. This panel controls the different type of filters that the user can apply to the buses. This is the bus info card. The card displays all the data about the buses. This is the confirmation dialog, a pop-up that is displayed once the user wants to use legal access services, like for example, reboot, relaunch, etc. This is the connection status. It shows if the app is connected or not to the Liquid Galaxy. This is the custom text field. It's used on the different parts of the app. This is the data map, the widget of the Google Maps that is shown on the home page. This is the orbit button that is used on different cards. This is the Pig Farm info card, the card that displays data about pig farms. This is the selection button. This is the button that is displayed on the home screen to select buses, environmental sensors, or pig farms. This is the sensor filter panel. It's used by the user to select the different type of filters that the sensor have. This is a sensor info card. It displays the different data of the sensors. This is the trail button. This button executes the trail of the buses. This is the main file, where the providers are declared, and also the navigation bar. This is my app's code. Now I'm gonna show you my app.
Let's see the settings page. Here you can connect to the Liquid Galaxy by putting the data and pressing connect. Also, you can scan the QR to directly have the data. Here you have the Liquid Galaxy services, where you can shut down the Liquid Galaxy, reboot, relaunch, etc. In the app settings, you can change the color theme of the map, like you can see. Also, you can change how the bus direction is displayed with numeric values or text values, and also you can turn on or off the colorblind mode. Also, in this page, you can find the help page where you can see data about the app. Let's go to homepage. Now, let's see the Malaga buses. As you can see, real-time buses are displayed on the Liquid Galaxy. Now, I'm gonna select one bus. Once the bus is selected, the data about the bus is sent to the Liquid Galaxy and shown in a balloon. Also, you can filter the different type of buses and select what type of data you want to see. Let's see only the line and last update. As you can see, this data also updates in the Liquid Galaxy. Now, let's see the orbit. Let's stop it, and now I will show you the trail of this bus. The trail can be stopped by the user, or it will stop itself once it reaches the current position. Now I'm gonna turn on the colorblind mode to show you the Santander environmental sensors. As you can see, there are weather sensors and noise sensors. Let's select one weather sensor. You can also filter the different type of information about the sensors. Now, let's turn off the colorblind mode and see the data pig farms. You can select the farm, the year, and the batch. This is everything my app has.
And now I'm gonna talk about my personal experience during this GSoC 2025. I have really enjoyed being part of this program, and I have learned a lot during these months. Some things, like the connection to the Liquid Galaxy or sending the logos, worked on the first try, while others, like the balloons or the bus trail, gave me some problems. But I learned a lot through overcoming those problems. I want to thank my mentor for answering my doubts during the weekly Google Meets. With this, my demo day video ends. I hope you have liked it. Bye!
Hey everyone, my name is Oscar. I've been a long-time contributor to the Liquid Galaxy Lab organization, and for the past few years, I've also had the pleasure of mentoring for the Google Summer of Code program with them. I wanted to share a little about my experience, and I have to say that so far it's been incredibly rewarding to me. Honestly, I'm so impressed with the entire process. Like, the quality of both applicants, contributors, everyone we meet is just fantastic. And they come in so willing and motivated to push themselves and make a great impression. Also to get the most out of their summer. So for me, it's very inspiring to see them ready to build an amazing project. This year, just like last year, I've been mentoring contributors working on fascinating Flutter apps with some really interesting data visualizations. A common theme has been incorporating geographical elements. For example, using a Google Maps interface to display data in a very intuitive way. It's very exciting to see those complex ideas coming to life. My personal goal as a mentor isn't just about the final product, it's also about helping the contributor to the point, to the extent he wants to make their best foundation for the rest of their career. Because for many people, Google Summer of Code is like the first step in their professional life. And I really want to encourage everyone that participates to learn new skills that will be helpful towards their start of their career and long, very long after the summer is over. And that's it. I don't have much else to say. Like watching everyone succeed and become a better engineer is probably the best part of the program for me. And honestly, I can't really wait for the future editions to start already. See you, everyone. Ciao.
Hi, my name is Michael Gibert. This was my first year as a mentor in the Liquid Galaxy project. I was mentoring Mark in the data space visualization for Liquid Galaxy based on the viewer data. I was helping Mark to find out the data to visualize and also helping him with the user interface and experience. For me personally, has been a rewarding experience working with young developers as Mark with this kind of new technologies.
Hello, my name is Lucia. I am from Spain, from Alicante specifically, and I have completed my bachelor studies in the UPB, which is Valencia's Polytechnical University. My project is pretty special, I think, because it's not a conventional app. It's more designed for future contributors. So my project has the part of the coding is as important as the part of the README. This is because all the coding, as I will explain in just a minute, it's a very basic app. I have researched apps from different years, from different contributors, and I have chosen what I think are the minimal screens that every GSoC app should have. And I have done a really basic app with all those screens, and also have implemented some optional features that maybe future contributors want to include in their apps. So going through the app, you can see the minimal screens, and also if you plan to develop an app, you can see some additional features you can implement. Also, if you go through the code, every single line is commented, every single file, every single line that can be commented is commented, so you can, if you want to develop a project in the following years, you can use my repository as a guide so you know what everything does. And the README is also very important because it complements the code. It explains a bit more about what the code does, how Flutter works, if you have never worked with it, how to set up GitHub, etc. And also gives a lot of information on how to set up your project, how to start on GSoC, how GSoC works, etc, etc. So first, let's go through the code. Okay, so let's start with the code. First of all, what I will explain is the main Dart file, which if you have never worked with Flutter developing an app, this is basically the main entry point of your application. So as you can see, here you have what this file is. You have a little explanation for the file. This is the same for all the files that we will be seeing. And also we have all the import packages, what each package does, etc, etc. The main function, you can see everything is explained here. You can, if you look at this part of the screen, you will see that there's more green than any other color because everything is filled with comments, so you can understand exactly what each line does. It's really important that we use these providers. The theme provider is used to change the theme of the class, basically to change the dark mode from the light mode, etc. And the settings provider is used to change the size of the text. And then we have the LG service, which is really important because when we connect to the Liquid Galaxy, we want that connection to be available, that state to be available through the whole app. So it's really important that we put this here so that happens. yeah, we have here the basic main Dart file things. Everything again is explained, how the Dart model works, everything. So here we go. The first widget that the user will see is the splash screen. So what is the splash screen? This is typically a welcome page that appears when we open an app. In the case of GSoC, they should have all the logos of all the technologies that were involved in the application. Of course, the logo of your own application, the logo of Liquid Galaxy, the logo of GSoC, etc., etc. This is also explained through the code, but also explained on the README. So we have everything here commented again. Everything here. We have timer of 3 seconds, which is how much this screen will last. This is you can basically choose any time you want the screen to be on the screen, but the recommended is 3 seconds. Yeah, we have all of this that is explained, everything. So what I did, this was only my choice, you can of course put the logos however you want on the screen, is put first the logo of my application and then all the logos of all the technologies that I used. And in order to do this, I did a reusable widget, which is explained here, which is the logo image class. Basically, because if I'm going to be displaying the same image, not the same image, but I'm going to be displaying a lot of images together, this is way easier to just reuse a widget. So after the splash screen, what we will see is the main screen. From the main screen, it's important not to confuse the main screen with main.dart. Okay? The main screen appears to the user interface as a main screen. From here you can access the connection screen, the help screen, the settings screen, and also the optional features screen, which I will be talking about in a minute. So as always, we have everything commented here. We can see the title, everything, the colors, everything is explained here. Also, for example, I chose those colors here, but if you wanted to change colors, I also explain here what you could do. So everything is commented to explain what I'm doing here, but also if you want to innovate, so you know how to innovate. So here I just added my logo again to the main screen. Here from assets, I just put welcome to the LG Master Web App, etc., etc. Then we get to the buttons of the screen, which we will see on the demo. We have first the one related to go to the connection screen. Then we have the one related to going to the help screen. Then we have the settings one, and then we have the optional screen one. And again, since I'm going to be displaying a lot of buttons, I just did a reusable widget and reused it to display all the buttons, etc., etc. And that's pretty much it. So the first one we see is the connection screen, which is probably the most important one, because it's important to remember that if your application does not connect to the Liquid Galaxy, you will not pass GSoC. So here is everything related to the connection of the Liquid Galaxy. So in this screen, it's really important that we import this file, LG Service Dart, which is here, and QR Dart. So what does LG Service Dart do? So the connection screen file, what it does is the user interface, and the LG Service is the logic behind the user interface. You can see here that everything is, as always, commented. I created an LG connection model with username, IP, port, password screens, basic features. I just did everything here. So the LG connection model gets these values by default. So then we have the different functions that we will be using on the connection screen. We have update connection, we have save to preferences, we have load from preferences, of course are linked. Then we have the LG service class, connect to LG, really important one that if you read through the code is used a lot. Then we have, of course, disconnect. If we connect, we have to disconnect. Queries to send text to the Liquid Galaxy, basically to send commands to Linux. then calculate the rightmost screen and the leftmost screen in order to send the balloons and the logos and the KML and everything. Force a refresh. Again, everything is explained, even the Linux commands, so that you understand what everything does. The fly to method to move to specific locations. Start connection check to check if the connection has started. Check connection, check if the connection has been made. Clean KMLs. And then clean the logos. Yeah, clean the balloons. Clean all. Yeah, I'm just going to go really fast through this because as you can see, there's a lot of code. So yeah, we go back to the connection screen, and yeah, that was all the logic, and this is basically the user interface. So you see all of this. I'm going to go pretty fast through this because we have a few more screens to see. So here's the connection, everything related to the connection to the Liquid Galaxy. Yeah, everything is connected again. These are how we're calling all the methods from the LG service screen. And then if we go down, we can see that we have here the user interface screen, and we can see the different buttons that we can, well, we have the input fields to introduce the username, IP, port, password, screens, etc. Then we have the different buttons that we can use to access to different connection functions. So we have saving the credentials, connecting to the Liquid Galaxy, clearing the KMLs, and then rebooting the connection, disconnecting from the Liquid Galaxy, relaunching the Liquid Galaxy, and shut down. So after this, if we go back, we can see the help screen, which is doesn't have a lot of difficulties to understand what it does. Basically, it just gives information about what your app does exactly and the team that contributed to do it. Here you have a little explanation of what my app does, and of course partners and supporters. I put the logos of the different partners like Flutter, the Jada Labs, etc., etc. I put a link to the GitHub of the repository. Then you can visit the Liquid Galaxy site and learn more about GSoC, etc., etc. And then the project team with the names of the contributors, my mentors, and the team at the Jada Lab, which is also really important. And yeah, this is the going back button, which I added here, and of course allow embeds class to, as well in social icon class, to reuse the same class to put all the buttons and the images. Then if you go back, you can see the settings screen, which imports the theme provider and settings provider that we have here. The settings provider is to change the size of the text fonts. You can see everything explained here. I just chose some values, but you can basically choose any value you want. And the theme provider is to provide the dark mode and the light mode. So they're just through the whole app, so because if you change one of these things in the settings, it would change through the whole app, but you understand what I mean. So here's the settings, yeah, everything. We can choose the dark mode option, also the font size options, everything, blah, blah, and the going back button again, because honestly I just felt like putting it because it felt a little bit empty otherwise. And finally, we have the optional screen buttons. Oh, sorry, I forgot to mention that on the connection screen, we also use this file in order to scan and be able to connect to the Liquid Galaxy via a QR code. This is what the code, well, when we click the scan the QR code, we go to another screen, and it's this one. And from this one, the information we read from the QR code goes to the connection screen. So, going back to the option screen, which is the last one. From here, we can access the different optional features. These are not minimal screens, but this is features you can add as a future developer to your app that I think are really interesting. You can use an external browser to open a link. What I did to show this was create a Google Maps map and just open it and show it. Then you can send a KML to the Liquid Galaxy, of course. Then you can check the state of an external server, which I created the server here. It's not the server that is here is not the one that is running, it's running externally, but I thought it was important to add the code here so you can check the code I uploaded. Then you can also use artificial intelligence, and yeah, that's pretty much it. And then this is the interface, of course, all the values. So with that, we will have basically all the code of the application. As I said, the value is not on how innovative it is, but on how everything is explained. So now we will go into the demo. And also, as I said, documentation is really important, so I wanted to give a quick overview of all the documentation I made. It's accessible on GitHub, but I just wanted to give a quick look of all the documentation I made for this project. And yeah, I just wanted to put as much information for future contributors so they don't find all the problems I found while working with Flutter, because this was my first time working with Flutter. So yeah, I put everything I could think of here. And this is also, I also made a PDF of this so it can be easily distributed. So my experience with the whole GSoC program was pretty good, although I think the most difficult thing was, of course, to begin, because I had a bit of experience with developing with Android emulator and with VS Code, but I had never used Flutter, so I basically, even though I knew a little bit of Python, of HTML, etc., what I had to do was basically learn a whole new language from scratch, which was really difficult at first, but then I got the hang of it, more or less. Also, explaining the code, I think, really helped me to learn the language, because as I was explaining the code and I have doubts about what everything does, I could use those doubts to explain my code better. So at least I hope that everything I went through is useful for future contributors, so that they have all the answers in the same place and don't have to suffer as much as I did. Also, my project is a medium project, so I should have dedicated like 4 hours a day. I ended up dedicating way more hours to the project, but I think that's because I wasn't that experienced in coding and programming as maybe other contributors. But still, my experience was pretty good. There were times where everything was really difficult and I had a lot of problems with connecting and everything. But in the end, it all came out well, and I'm super happy about that, because I don't know, it's like, even at times where I wanted to give up and be like, this is never going to work, it ended up working. So I'm pretty happy about that, and looking now at all the job I did and all the explanations and all the readme, and thinking that it may be useful to future contributors. I don't know, it makes me happy. And also, I want to thank all the team at the Jada Labs, because they really helped me a lot with the application and everything. Well, me and all the contributors, but in this case I'm talking about me. And I don't know, I'm providing like comments and support about how the app is going when testing it on the Liquid Galaxy. And yeah, I would say my experience was hard. I had to work a lot, but it was definitely worth it.
Hello everyone, my name is Claudia and I've been a mentor this year for the Google Summer of Code at the Liquid Galaxy project. I've been part of this community for several years, first as a contributor and now as a mentor. And every year I'm amazed by the creativity and dedication of our contributors. I also mentored Lucia, who created a comprehensive GSoC beginner's guide for Liquid Galaxy. This isn't just a document, it's a complete onboarding experience for new contributors with step-by-step explanations, practical examples, a ready-to-use code repository, and detailed comments on every line of code. Lucia's guide is going to be a valuable resource for many future GSoC contributors, helping them understand technologies like Liquid Galaxy, Flutter, and GitHub from scratch. She's done an outstanding job, and I truly want to congratulate her as well for this excellent contribution. Mentoring Anishka and Lucia has been incredibly rewarding. It's inspiring to see how they started with an idea and through hard work, curiosity, and perseverance, turned it into something concrete that will have a real impact on the community. As a mentor, I've learned a lot from them too, about fresh perspectives, problem solving, and the power of collaboration across different time zones and cultures. I want to thank the entire Liquid Galaxy community, fellow mentors, and of course my amazing mentees for making this GSoC 2025 such a great experience. Congratulations again to Anishka and Lucia, and I'm very proud of you both. And to everyone watching, keep building, keep learning, and keep redefining what's possible. Thank you for watching.
Hello, it's Javier Mancho, and I'm presenting Voice-Driven Robot Goal Assignment System with Liquid Galaxy for the Google Summer of Code 2025. First of all, I want to introduce myself. I'm from Madrid, and I have recently graduated of Computer Science at the Universidad Francisco de Vitoria. Next year, I will start an Artificial Intelligence Master's degree at the Universidad Alfonso Jiménez Sabio. Once you know this, I want to remind you my project actual scope, which is to create an interface that allows users to control different robots distributed in different areas just by the voice. Here, Liquid Galaxy will act as the information display. To achieve this, I have created a system following this architecture. First, we have the client, which is a mobile application using Flutter, which will act as the interface for the user. Then we have the server, which is divided in two different modules. The natural language processing module in charge of converting spoken instructions into structured representation, and the fast downward planner, which is in charge of calculating the optimal path for the robot. Then, as I said before, we have Liquid Galaxy, which will act as a display, and then the ROS2 Humble Publisher, which will publish the information instructions to the robots. So first, let me introduce you the client, where we have the login page, where we can set the server URL. Then we log in using the credentials, and once logged in, we can use the different functionalities. The first one is to fetch robots, where we can select the robots and see the information. Then we can record the voice command, hey, move the robot to A7, for example. Then this will generate the transcription and allow the user to validate it. Once validated, the system will generate the predicate and also allow the users to validate it. Last, we have the Liquid Galaxy management, where we can select where we can control the Liquid Galaxy system by cleaning the KML or rebooting the system, and then the settings model, where we can control the account settings or the system settings. So to do so, here we have the different files distributed in 5 different folders, which are the entities. In this case, we have only one entity, which is the robot, the components of the front end, then the controllers, which are in charge of sending the request to the server, then the modals, which are the different modals of the system, like the server URL, the settings, fetching robots, and so on, and last, the settings, which will allow the users to control different settings like the IP or ports or the usernames and so on. So let me show you some code. Here we have the application, which is based on 2 different pages, the login page and the home page. The login page, as the video, as the demo has shown, we can set the server URL, and we can set the server URL here, and we can introduce the credentials. Then we have the main page or the home page, where we can control the robots and by recording the voice commands, selecting the robots, and so on. As I said, we only have one entity, which is the robot, and we are storing the information like the ID, the name, the coordinates, and so on. And then the controllers, where we have the authorization controllers to send to verify if the user is logged in or not. Then check connection to verify if the server is reachable or not. Then we have the Liquid Galaxy controller to clean KMLs, to reboot and to relaunch. Then the LLM to generate the predicates, the robot to fetch them, to display them, or to teleport, and so on. And last, we have the components, like the predicate component, which is this little model that appeared when we have to verify the predicate. The recording button, as you see, is the big microphone button to record the voice commands. And the robot component, which are those little modules of the fetch robots model. Where we can see the robot, if it is selected or not, and the information like the coordinates. Then the settings component and the account and the system setting tabs, which are the different modals, the different components of the modals. Then we have the transcription as the predicate component is the same. We can validate the transcription here, and last, the user setting tabs, which is the same as the system setting tab, but for the user account settings. Yeah, and that's it for the client side. Then we have the server. The server is the actual brain of the system, and is based on two different modules: the natural language processing module and the planner module. But we can divide the functionalities in four different classes, starting by the Liquid Galaxy management, which is in charge of controlling the Liquid Galaxy system. We have three different kind of requests: the navigation, which will be in charge of sending and controlling the navigation of the Liquid Galaxy. Then the robot, which will be in charge of displaying the information of the robot, the placement of the robot, and also the path of the robot once the instruction is sent. And last, we have the management, which will display the logo of the system, then to clean the KML files and relaunch on the robot, reboots the system. Starting with the natural language processing module, we have the speech to text. Well, once we have recorded the audio file, we combine it with the API key and send it to the OpenAI Whisper 1 model to generate the transcription. In this case, they move the robot to A7. To generate the structured representation, we have to use an LLM, but as a simple LLM is not enough, we have to fine-tune a specific LLM, in this case the Gemma 2 with 2 billion of parameters. And we have generated a specific data set with synthetic data simulating different instructions. And all of this combined using low rank fine-tuning, we have generated a new LLM model to generate the structured representations and to convert the transcriptions into these specific predicates at A7, for example. Once we have the goal, which is the actual instruction, by using a kind of the problem template, we can generate the problems to send it to the planner. Here we have an example where we have this blue text that will allow us to substitute the current position and the generated predicate by the information stored or by the instruction generated. All of this combined, using fast downward, we can generate an action plan, which is this kind of instructions like navigate from A1 to A4, and then from A4 you have to navigate to A7. So let me show you some code again. Here we have the server, which is divided in different files. Here we have the model downloading, then the different requests like the check connection, display logo, display the information of the robot, to teleport to different waypoints, display regions, clean KMLs, and then we have the KMLs of the play zones of the robots. Then we have the information stored of the robots. Here we have an example, the robot 1, which is located here. These are the center of each waypoint of the playzone. Then we have the settings, which follow this template and so on, and some statics here like the predicates. As I said before, we substitute these strings into the actual information stored or provided by the LLM. And last, we have here the different files to generate the images for the legends. Here to control the Liquid Galaxy by sending, for example, here a KML to display the logo, to clean the KML, as I said before, display the KML region for the robots, and so on. And last, the orbit builder to obtain the information and the orbit of a specific waypoint, and the planning utils, and so on, and the request bodies of each request. So we can check the endpoint summary using the Fast API documentation. Here we have the all kind of requests that our system allow. Here we have the check Liquid Galaxy connection, for example, which is a get. Then the display information, where we are sending the ID of the robot to teleport, also sending by the ID of the robot. For example, by getting the settings of the system, which will return this kind of JSON file, which contains the username, password, Liquid Galaxy username, and so on. And also we can update the settings by sending them. And for example, the speech to text service, where we are sending the audio file in binary, and the prediction, where we are sending the LLM the validated transcription, and the planner, where we are sending the goal and the name of the robot to obtain the current position. And at last, we have the ROS2 module. Once we have the plan, we can divide each action and send it to the publisher. And an action example is navigate from A1 to A4. First, we have to calculate the direction if it is straightforward, or if we have to move the robot. Then we calculate the distance to calculate the time of the action, and we will send this kind of instruction to the robot. And that's it. Now we will move on to Jada to check the demo in a real Liquid Galaxy system.
Well, and this is the real demo for my Liquid Galaxy application. First, we have to set the server URL. Once we have it, we test the connection and we save it. Then we can log in using the credentials here. We can fetch some robots here, and once selected, Liquid Galaxy will teleport us to the playzone of the robot and display the relevant information, such as the coordinates, the region, and the status. Once selected, we can send an instruction here by saying move the robot to A7. We generate the transcription and validate it, and then we generate the prediction. Once the prediction is generated, the planner will create the shortest path to the given waypoint. As we can see here, we move from A1 to A7. Once we have the plan, we can see the orbit of the robot here. And also in the legend, we can see the execution plan to reach A7 from A1. I will stop the orbit. Well, and that's it. That's my project.
This demo was recorded during a really special weekend where we met Andreu, we also met Mark, we visited Liquid Galaxy laboratories, and we had the unique opportunity to test our applications in a real Liquid Galaxy. During these 3 months, short months indeed, developing a project for Liquid Galaxy, I have learned a lot in terms of robotics. I have deepened my knowledge in artificial intelligence by fine-tuning Gemma 2, using low-rank adaptation. I also learned a lot of ROS2, understanding how it works and how the nodes communicate, publishers, subscribers, and those things. Also, I have improved developing systems using Docker by delivering a system capable of being deployed in a real and physical server. I improved programming Flutter applications. And all of this is thanks to Andreu for the opportunity, but also thanks to Moises for being part of this, for helping me during these 3 months. It has been a really short time, but really challenging. The pace of GSoC is quite fast, but the outcome is truly positive. I live with new knowledge and the satisfaction of working in such a positive environment. So thanks to Andreu again, thanks Liquid Galaxy, and thanks GSoC for this opportunity. And I hope to stay close.
Hi, my name is David Calero, and I'm currently studying the International Baccalaureate Diploma Program, IBDP. And this year I joined the Google Summer of Code in order to get involved with scholarships and looking forward to university and even work. I started by joining meetings, early planning meetings, in which the aim was the improvement and refinement of the contributors' projects and documentation and preparation for them to be selected for the scholarship. And once they were selected, I took part in 2 specific projects, GeoVision AI and voice-driven robot. I participated as a trainee contributor, which meant my main role was basically note taking about any discussions made during the meetings, any errors encountered by contributors while developing their project, and their goals for the next week. From this, I deepened into and learned about the Google Summer of Code program. I got to know more about Google's scholarships, and I was introduced to the Google Galaxy's platform and technology, and I was presented with technological and coding concepts that I hadn't seen before. I got to work with people from different backgrounds, and even made good friends, which made the experience even more rewarding. Overall, this experience has given me valuable skills and a broader perspective on technology and scholarships, and Google scholarships specifically. And I look forward to joining Google Summer of Code's next year's Google Summer of Code, and building on what I've learned so far. Thanks.
So, hello everyone. I am Jayavardhan Shukla, and I am from Lucknow in Uttar Pradesh in India. So basically, I am a final year undergraduate student at Visvesvaraya National Institute of Technology, Nagpur, which is situated in Maharashtra, India. I am basically contributing to the Liquid Galaxy organization via GSoC this year, and I have basically worked on the project Google Research Open Buildings Data Visualization, which is an application that leverages the Google's own Open Buildings V3 Polygon dataset, and basically visualizes all the footprints that are there in the dataset for the global south in the Liquid Galaxy rig. So over the next few minutes, I would be walking you through the entirety of my application, including all of its features and capabilities. So thanks. Yeah. So basically, this is my code base here. I have done the whole project in the Android Studio itself. Right here is the VM emulator, which basically replicates the Google Pixel 7a device configuration. So basically, my project is structured this way. My assets folder consists of all the assets and the required images and other documents which are necessary. And the whole project, main UI of the project is here in the UI folder. Here you can see there's splash screen, there's settings screen, onboarding screen, map screen, and health screen. So these are the main default screens of my project. The most essential one of them is the map screen. So the screen that you right now see see is the map screen. Here the app works this way. So by default, you would be seeing a specific city. You can change your default city from the settings itself based on whatever choice of city you have. So you can see that we basically have more than 120 cities to visualize. So the user can select any city from the list of cities. The cities are divided on the basis of the continent. So by choosing it, the map would update to the new city itself. Like if I select Nairobi here, then this map would take me to Nairobi, and then the default features will start. So the main crux or the main usage of the application is this way. The map would show these overlay grids. You can see that these grids are size basically square shaped, specific covering specific area of the map. So the user can increase or decrease the area covered under the grids. First of all, by using the right side overlay size button here. By increasing or decreasing the area here, we can cover the entirety of this particular area. So all the buildings in the or basically n number of buildings within this particular region would be visualized to the liquid galaxy. So we can choose any specific area here, and accordingly the whole thing would be shown, and the number of footprints inside this area would be visualized. So a user can also zoom into the map, and by zooming in, we are basically lessening the area under the coverage of a specific grid. We can zoom out of the map to increase the area, and basically this is how we can control the grid map structure. So by clicking on a specific grid, the Liquid Galaxy or the whole mobile application loads up the content. So we can see that there are three main tabs here. The statistics tab shows the current building statistics. As we can see that in this particular region, there are 20 buildings covered. The average size of each of these buildings is around 64 meters square. The confidence distribution basically shows how many buildings are having a specific confidence score. So let me discuss about the confidence score briefly. So we would go to the help section to understand what the confidence scores are. So the confidence scores are basically the Google's way of saying that the footprints which are returned to the user are accurate to what degree or what probability. So the what probability is it that the footprint bounding box returned by the Google API is correct within its specific limits. So these buildings show that how reliable the data from the Google Buildings data set is. So this is how the whole application usability can be understood from the help section. So we can see that there is also a start building tour and a 360-degree region orbit. The start building tour basically navigates from each building, from one building to the next. So it would start from the first building and take you to the very last building, and then the tour finally ends. The user can also decide to close this tour in the between. I would give a demonstration of this in the Liquid Galaxy when we would use that. So the start 360-degree region orbit would do orbit around that specific region. So it would cover all the building footprints that are there. It would start from the centroid of that region itself, or from that part where the building density is more is the highest. So the next thing is the buildings tab. In the buildings tab, we can see that there is this search bar. There is a plus code associated with each building. So the plus code is basically you can say it's a identification mark associated with each building. It is made up of latitude, plus sign, and then longitude. So these plus codes indicate where a building is located. These are mostly used in the KML and the Google Earth, basically Google Earth mostly. So if we specify a plus code to the Google Earth, it would take us to that location. So these plus codes in these buildings will basically show where these buildings are located. We can see the average area and the number of vertices or the edges, sorry, number of edges that this building has. So we can see the 14 points refer to that this building is having 14 different edges. So its whole geometry consists of 14 edges. This building's whole geometry consists of 9 edges, and so on and so forth. So we can click on this I button right here so as to see this particular building in the Liquid Galaxy. If we are interested in seeing the whole region area, like all 20 buildings at a single go, then we have to click on this Visualize Region button. So this is how the whole building is app is structured. We can see both the singular buildings as well as region as a whole. So apart from that, there is this details tab. It just shows generic details about the place or basically the region under consideration, the coordinates of the centroid, the region size, which is 1.23 kilometers square. The size can be adjusted by changing the size of the grid boxes as I have shown earlier. So there are other technical details associated with this, which can be of interest to them. So this is my visualize results tab. Finally, now the next thing is the search bar. Using the search bar, we can search for any place in this world. Like for instance, if I search for some city like Nairobi, so we would be seeing all the results associated with it, or let's say Lagos. So yeah, this is it, the Lagos, Nigeria. So the search bar essentially takes us the map to that particular location. and then we can select from any point where this is. So this is also synchronizable with the Liquid Galaxy. So the Liquid Galaxy map would also move accordingly as the search bar proceeds. So the next thing is about the presets. The presets are some of the places where the user can go to by default. So there is, for instance, this place called Angkor Wat. If the user clicks on this, then the user would be taken to Angkor Wat, and all the 20 buildings associated with that place would be visualized here. So this is how it is. Then we can also see each specific building from the buildings tab as specified earlier. So we can, in the presets tab, there are both monuments as well as cities. So there are some preset cities to look forward to that the user can visualize, and the monuments. So currently there are 5 monuments as presets. So these are basically the about the presets. So the next thing is about the usability of the application. Usability is enhanced by using two different modes, which is the dark mode and light mode, as themes for the user. The user can select the dark mode or the light mode as per their preference. The whole design of the application is done using material theme, so that all the new latest material design considerations are taken care of. The next thing is about the free navigation mode. So the free navigation mode is a specific tool designed for the user to roam around the map freely, so that we can see that when the free navigation mode is open, the user can freely navigate the map any as per the any place they want to go. So they simply can navigate the area, and then they can choose where they want to see and what places they want to see without ever having to choose a specific grid, which is the default behavior of the application. So we can disable the map and then go on to see other features. The map is multilingual. It is available in 9 different languages. These are the main languages which are covered in the global south, since the datasets, the open building datasets availability is restricted to global south. So all the important languages that are spoken here are taken care of. The user can choose any specific language, and the whole app would load in that particular language. So this is about the language thing. And these are basically the features that are there in the application. Now let me quickly go through the whole code base and how the project code is set up. So the project code is inside this lib folder. Here we can see there are various different directories. There is this components directory, which consists of a few components that are used in the screens of these applications. The main screens are defined in the UI tab, here UI directory. You can see there is this help screen, the demonstration of which I have already given. There is this map screen. So the map screen is where I am currently going on, which is the default screen for the application. Then there is this onboarding screen. The onboarding screen comes at the first instance when the user logs in. The settings screen is this one, where the user can choose whatever settings they want. And finally, there is the splash screen. So the utils tab consists of the utils documents, that utility documents, such as the app colors. The app colors define the theme for the app, and there are some other files as well. So the main file is this main.dart. It basically starts the application over, and basically loads up all the initials that are required, such as initializing our LG service, which is used for connecting to LG, and so on and so forth. So there's also a lot of chain notifiers associated with it, which are used as language and theme providers. So this is the applications. Our applications are basically designed. So you can see that different components have different files here. The I10 components is basically about localization. It consists of all the localization files, which supports different languages. And models tab consists of all of our models, including the building data model. The building data model consists of information about each building. We have used it extensively in our map screen as well as our bottom sheet component. So if we go to the components tab, the most important one is the selected region bottom sheet tab. So this is the tab that comes up when we click on any particular grid. So we can see that this particular grid doesn't have any buildings, so it shows 0 tabs. This particular grid has some buildings, so it basically loads it and then shows the number of buildings that are there. So preset search preset consists of the preset tab search behavior. So we can search for any particular preset using this preset search widget. The language selector is used for selecting the language, and the default city selector is used for changing the city from the settings. So when we user selects a particular city, then corresponding the map gets updated, as I have shown earlier. So this is the behavior associated with these files. The preset location model is used for setting the preset location. Default city model used for loading default city. Overlay model is used for setting up the map overlay tiles. API service is the file from where the API fetches results on the Google Open Building polygons, and then parses it parses it from GeoJSON or JSON format into to get all the data from, extracts the data from this JSON, and then basically creates our own custom KMLs, which are then sent to Liquid Galaxy. So the default city services are just for the residual service section. The next thing, most important one, is the LG service. So this LG service is where all of my Liquid Galaxy control functions are defined. The whole application uses this LG service to send all the relevant files to the Liquid Galaxy. All the important methods like slave refresh, clean KML, as well as sending functions for sending the KML for the specific area to Liquid Galaxy are defined in the service class. So this is not the most important file in this application. Then we have already talked of UI and other things. So this is the overall code structure. The KMS tab is the one which consists of JSON for all the preset KMS. So the application doesn't load the data for any preset from the API. It gets loaded from the JSON file which I have defined here for any specific place. We can see that all the JSON entries are defined in this. So these are already fetched results from the API, and these are used for visualization for presets. So this is it about my application. I would give a demonstration in the Liquid Galaxy. So basically now I would start with my visualization part. On the left is my mobile screen. So now if I would click on any specific grid, so the loading appears for that specific grid, and all the buildings get loaded and fetched from the API. So now if I click on the visualize region button, it would just show all the fetched buildings in the Liquid Galaxy. So we can see all the bounding boxes are appearing. So this shows that basically buildings are then created in the LGD. So now if I click on start building tool, it would just show each of the buildings that are there in this tool, and then would go from one building to next. So I would just stop the tool because it would just rotate for 20 buildings. Next thing I can show is that at the bottom there is also this orbit button, so that it will start orbiting when clicked. So now I would move to the buildings tab. Here we can visualize each building one by one if required. Let's click on the cities tab and visualize any city specifically. We can also visualize these places as well. So let's click on Cairo, or Nairobi, let's say. So 20 buildings are fetched from the JSON file, and then these are visualized as well in the Liquid. Yeah, so we can see all the bounding boxes appearing. So this is it for my application. Thank you so much. So overall, the GSoC 2025 experience was very challenging for me. I learned about a lot of things, especially related to the application testing and creating comprehensive solutions. When one approach fails, then diverting and switching to another approach. This has helped me a lot in being a better software developer and creating a product that users can actually like. I would specifically talk of the Liquid Galaxy organization. The mentors here are very helpful towards each of the contributor, and they are very patient and understand each requirement very carefully. And so basically, I'm truly thankful to the organization to be able to provide me such an opportunity to learn and grow and to think beyond my particular zone of comfortable thinking. So I am very thankful to GSoC and to Liquid Galaxy specifically. Thank you so much.
Hey Liquid Galaxy community, this is Mentor Yash, and I wanted to talk about our contributor Jayavardhan. I have been mentoring him for this Google Summer of Code 2025, where he developed the Liquid Galaxy app for Open Buildings Visualizer. His Open Buildings app is based on, or the idea is inspired from Google research. They have a building visualizer or a tool that has a lot of data for the southern hemisphere of the world, and a lot of 3D data set with confidence value that could be shown in a very clever way and visualized in a very immersive manner over the Google Earth. So me and Jayavardhan have been trying to tackle some of the visualization issues, how the presets work, how the pre-calculated regions have this wonderful visualization. I am happy with Jayavardhan's focus on the UI part. He has been taking care of how would the UI look. He has been taking some considerations and responsibilities over how some of the buttons would work and be effective. Whereas we are also tackling and I'm helping him on the UX part, so the user experience where let's just say a 3D building should be zoomed in much more, or something like their particular bearing and tilt angle so that we could make it perfect. I have been talking to him about what are these spaces where he can use the best visualization knowledge, as well as have some kind of a foundation over how to present stuff. And I'm very confident about Jayavardhan and his work on the buildings visualizer. I also very recently had that published over the Go web store, and I'm really happy how things are going with him. Uh, what I do want from him is to really improve on the polishing aspects and those parts. And what I believe that he has done really well is he was able to understand the problems, he was able to understand and develop like his own solutions, and also take help from the existing repos and applications such as using the La Palma or using the AIS visualizer by Rufaida. So I'm really happy about how he has been tackling this, and I'm looking forward him to get a very successful Google Summer of Code.
Hello everyone, my name is Devti Gadani and I am from Ahmedabad, India, and my project is on the Liquid Galaxy Airport Simulator, and my university is Government Engineering College Gandhinagar. So let's start. First, going to the code, I will explain the some of the parts that are needed to you to explain to see the code and explain it. So basically, what is my controller? What is my project? My project is based on the airport controller, in which you are controlling the airplanes from one screen to another and not making it to be conflicted, or it going to be in another direction, or in the direction that has to not been gone, and making it proper to the direction it has to be gone and deploying it to the proper airport. So let's start exploring my code. So these are some of the input that are has to be taken by me to manage all the state of the airports and all the things. And, this plane variable is mapping all the screens airports into it, like the first plane has a 2 airports, second place has 4, 3 has 5, like that wise. So, and this is a function for processing, like that how much rig you are presenting, like you have a 5 rig or a 3 rig, that's way. And these are the function for the helping, like finding the aeroplane from the array, finding the width from the array, etc, etc. Yeah, first we connect, then we emit immediately the one socket that name is new screen, in which we are passing the number of screen that user has been given to us and which screen number it is. And let's take a look more. I will be explaining in the short all the things because I have a time limit of 10 seconds and I will go to code that is big. So yeah, this is a create airplane, in which all the plane are been created, and then call to the and imitated to the client side, and client will catch it the socket and will deploy the aeroplane over there. The main part is a transfer aeroplane, in which likewise why it is a main part, that is because when we are transferring from 5 plane to 1 plane, 5 screen to 1 screen, then we have a perfect value that x is always be to 0 in the screen. But when we are going from 1 screen to 5 screen, then what happens, we are not having an exact value, because the fifth screen can be a smaller, can be a bigger, or its height is more, it's in any way it's not perfect as one, or not same as one. So I'm calculating the means calculating taking the width from the screen on the starting of the game, like on this new screen image, then we are emitting back to the server that post width, in which post width are coming for all the planes. And then we are fine, and I'm taking a minus number, in which I am supposed to place the plane over there, like from 1 screen to 3 screen, then -3 will become, then it has to be gone on the 3 screen, and from that -3 I'm taking out the value of the width and pasting, or we can say keeping in the x value at the plane data for that plane. Yeah, then it is all done for 2 3 4 5 1. This is the function in which the plane is added automatically if you tap on it and all that, and we like that wise. These are all function for small tasks, like updating the aeroplane left, right, and send command, update command, select command, submit plane, deselect plane, airport positions. See, I'm mapping all that position over here, and this is useful in managing that. From here the plane will be going, from here the plane will be coming, and that all. Yeah, you can see post it and success. All the socket are emitted from the server to the all the clients. So it will giving you the success, result, error, wrong exit, etc, etc. Game over, game start, all that function that are needed, and the start time, stop time, to restart, to pause, to resume, and all things stuffs are done over here. Sometimes the what we say, all the states are been cleared to manage perfect algorithm and to keep the state alive. Yeah, to keep the state alive, I have been passing the heartbeat function, in which I am keeping it to in socket for at 5 seconds every 5 seconds, imaging socket from client to keep server and client relation alive. And let's take a look from airport games. So this is basically a function like taking the canvas with then mapping it, dividing it, creating spacing, and then create a master map from it and place all the grids everywhere. And then I'm taking the airplane images like SVGs for red, like white, and all that, or changing the color sometimes. So yeah, you can see that it's a plane for SVGs. Yeah, and this function is for generating the map based on the screen number. As the first screen number will generate master map, second will generate master slave map to, and go on, as I've done over here also for 5 screen. And these are the functions from where the screen emerge, and it will give the post width data that immediately, so we can get the exact width of the screen and manage it perfectly. New screen function the first time, and this is the function, this is a code like this much for managing the planes, like from last offset to first offset, like managing the plane on the grid, like it is off of the grid and it is coming to a grid, but the first in the between the screen is been gone, so we are mapping it to the last offset it is, so it will be coming from that area. The the map will draw entire map of the screen, and these all are the function that is been map used for every plane, like going to the one side, up side, left side, right side, altitude, latitude, downwise, upside, that's way. This is for animating all the things. It is a function of the canvas in which it moves the plane, redraw it again and again and again, we view that it is going in the plane. Yeah, not much more, I will time limit. So yeah, thank you. All the code has been explained you from my side, and one thing I would explain is that yeah, this is a for render transfer, that canvas width comes, then it goes like to screen for screen, as I've told. I'm passing emitting the data from over here. Yeah, same for 5 screen. Nothing, the position airport, it will position all the mapping variable will be done over here at clear airport. When the clear airport will be coming, no, yeah, all these things are basically done. Error pop-up, submit pop-up are all be done, and checking by the screen value that it has been to shown over here or not to shown over here, else, etc. Thank you, and this is my main Dex HTML in which all the things have been done, like may canvas drawing, error, info label, success data, scoreboard, container, all things as over here. Thank you for all. I will play a demo of my game, and this is a helper function in which we are generating a map. How will be generating and giving us the grid position by a width and height calculated at runtime. So yeah, thank you.
Turn right to 180 at 4,000 feet. Roger. EWD orbit right at 4,000 feet. Roger.
Vaccine experience I got from the code and GSoC 225 and with the Liquid Galaxy community is like making the connection with each other and performing your task time to time, and some of time you will feel like this is why not working, so you can go and check out the other repository that has been delivered the past project, and you will get the ideas from that, and all the types of some of the problem are being faced at some time that are critical that you have to solve, like my wise some was the problem that has to be solved was important. So all the personal experience I get from here is much better, that will make my personality and all things good and throughout the life. Thank you to the Liquid Galaxy community to making me the part of the community and for selecting me for GSoC this year. Thank you.
Hey guys, it's Vedant Singh, mentor at Liquid Galaxy. So making this video to share my experience mentoring Google Summer of Code 2025. So I was the primary mentor for Dev Gadani working on LG Airport Controller, and I was the secondary mentor of Sanya Singh working on Catastrophe visualizer. So, talking about Dave, um, he has definitely exceeded my expectations. I'll tell you why. Because earlier I had worked with him, and he has been a long-standing contributor. He's also worked on LG Wiki as well. Credits to him. He is definitely a hardworking guy, but I have a metric to compare with from the past since I've worked with him, and now, um looking at his performance, he has definitely exceeded my expectations as well as the expectations of his other secondary mentors, and I'm super happy and super proud to see this, and super happy for him. I am very excited for you guys to check out his project. His project is going to be really good. I definitely suggest you go ahead and check it out as soon as it's launched. And then talking about Sanya um, has unfortunately been facing some challenges overall, uh, progress wise, but she's a very strong girl. Life happens, things happen, and but bottom line, she's trying very hard. I hope her project turns out very good and you guys get a chance to check it out really soon. And talking about my experience has been really great, honestly, because of course there were a lot of challenges as well, but um, at the end of the day, it's just joy, right? So of course I got to learn a lot from these contributors as well, of about how they navigate through the coding period, because every time it's a different lesson. Even you get to learn with the contributors, but the real joy which I found overall, and that's why I'm a mentor, is me sharing my teachings to the contributors, which actually help them navigate through the coding period and become a better contributor, become better engineer. Because I remember when I was a contributor, my mentor also used to guide me a lot, and now when I do the same, and it actually helps the contributors and actually adds value to them and their project, I just get a very strong feeling of joy, which is something I'm chasing. And I guess that's why I'm here. That's why I'm a mentor uh, in these helping these open source softwares, especially Liquid Galaxy. I love it overall. Thank you.
Hello everyone, my name is Rosemary, and what Liquid Galaxy means for me is learning and collaboration. Being part of this project has given me the chance to discover new ways to apply technology to projects with real impact. What I find the most inspiring in the community behind it is that everyone is so passionate about innovation, creativity, and sharing knowledge that it's not just about technology, it's about people working together, learning from each other, and growing as a team. I feel really grateful to be involved as a listener and mentor because every meeting is a new opportunity to learn something valuable. Liquid Galaxies prove that when we combine curiosity with collaboration, we can create something truly powerful and meaningful. Thank you.
EAC turn right to 045 climb and maintain 2,000 feet cleared to takeoff. Roger. Turn left to 180 climb and maintain 2,000 feet cleared to takeoff. Roger. CAC head to 0 at 2,000 feet. Roger. EMA orbit right at 4,000 feet. Roger. ETW turn right to 180 at 4,000 feet. Roger. CN turn right to 135 at 4,000 feet. Roger. ETW orbit right at 4,000 feet. Roger.
Hello everyone, my name is Devanjan Naskar and I'm a third year electrical engineering undergraduate here at the Indian Institute of Technology, Kharagpur, and I'm a contributor in the Google Summer of Code 2025 under the Liquid Galaxy project organization. My project in the Liquid Galaxy organization is robotic simulation for Liquid Galaxy. So what this project does is it leverages the existing ROS2 framework and Gazebo to simulate and present new age robots like SOARM 100 and AmigaBot in the network multi-screen setup of Liquid Galaxy. So that's what we are going to see today. So we will deep dive into our code now. First we will see the code of the app and then move to the robotic side of things. So let's see the app once. This is the app Robotics LG and we will open this. So the structure is that it is divided into two sections, the controllers and the views. The views actually are the visual elements that you can see, and controllers is the backend that runs in the computation side and it supports the views to give you accurate results. Now this is the launching page of our app. So the navigation is an indexed stack so that it loads only once and not on every tab you do. So in the main Dart, this is the code and it uses the gatex for state management and also the gate storage for local storage. It also uses the WebSocket channel and the QR code package so that our app can function correctly. Now the launching page is the controls one. So if you go to the home page, you can just see that this is the index stack we were talking about, and the navigation controller actually initializes a 1, so which is the binary form of, not the binary, it is the computer form of second. So this is the launching page, and in the nav controller, every time you tap on this, the nav controller changes the tapped value, and that is how you navigate. Now going to the control side of things, so the controls actually has three modes: the SORM interactive, the SORM demo, and the Amiga bot. So you can see that by tapping on this drop down menu. You can see you can control three robots right now: the SORM interactive, the SORM demo, and the Amiga bot. For each of it we have these views, and under that the robots directory, and in this each of the view is connected. So the Amiga has its own description, and okay. Okay, so the Amiga will have its own description, the ARM demo have its own description, and for example, the description is this right now, and if I switch to the model, the description changes, and the connection is the same, and the joystick format changes. So each of them has different joysticks and different descriptions. So this is what is in this directory. Now we will go to the controller side of things. So for example, if I move this joystick, what happens? That is controlled by the controller here, the controller. And if you go to the controller, you go to the robots and say, I'm now controlling the ARM controller. So ARM controller in each joystick change, these all things happen. You can see it is written here. Now the controls actually controls the connection side of things. So if you connect anything with your IP address and hit connect, so the controls is the one that initializes the connection and maintains it. Right. So the next thing is that we'll go to the LG tools, and on this LG tools you can just go to LG tools.dart. This is the view. This provides a slider of zoom and the buttons to launch your stream or launch your logos and end your stream, as you can see. And each of these are connected to the settings controller. So the settings controller has many functions and each of these are connected accordingly. Okay, so next thing is that if you go to the settings now, this has the QR controller. So the QR scan widget, and the scan actually happens through this code which scans, and when the scan is successful, you can see I'll just do a demo scan here. So this is the IP address and LG username, all are now uh, free. So if I just scan it, you can see what happens is that if I just go and scan it, see what happens. So this wall contains a QR widget, right? QR image, and you can see all are auto filled. So it just scans, shows you that it is processing some inputs, and then uh, gives all your details at one place without having to type each one manually. Okay. Now this is all controlled by the QR scan view and the settings controller. So the settings controller also uh, initializes the SSH connection and maintains it. So that is what it does. It also auto connects every time you open the app for the first time. And now the about screen is pretty simple. The about screen is actually the simplest of this all. The about screen just shows you all the data about the application, the credits, who it is created and maintained, who was the mentor, and who is the organization admin. Now the links. This leads to the project repository. This is the GitHub of the creator, LinkedIn of the creator, that means me, and this is the email. Right. Next, this can also reboot, relaunch, and shut down, and this is all for the app side of things. Now let's go to the robotic side of things, how everything works there. So that I will have to open from GitHub, and this is the up-to-date latest branch for uh, setting up the Docker server and running it. So LG Robotics Docker server. And now if you go to this README documentation, you will see the operating system required, what are the prerequisites, and you can just follow the instructions and set up your Docker server. But we will deep dive into the code right now. So as you can see, at the entry point of this uh, Docker server is choose robot.sh, which is a bash script. So we'll go to the script to see what happens. And if you open the script, you will see on each choice a compose file is built and run. So each of these compose files are here, and this compose files actually utilizes the NVIDIA container so that the GPU of your system is used. And when each of these is launched, it builds the container locally, stores it, and then runs on it. Okay, so the next thing is that what it runs, right? So what it runs is, you can see each of these folders has a, not the assets one, this Amicabot package, Flask server, robot package demo, and robot talk package. Everyone has their own Docker file, which is followed while they're trying to build the image. For example, let's dive into the robot package for now. So in the robot package, you will see this is a proper ROS2 package that contains the URDF, the launch files, the controllers, the configuration of gazebo, and also the ROS2 control package. And this is the assets that is used to launch the robot, as it is a 3D mesh that we are uh, building. It is not URDF, pre-made URDF geometry shapes. So as you can see, this is the structure of the ROS2 package. Now let's go to the hierarchy of how things work. So first, the entry point, not the entry point, basically the URDF that you will see on the screen, the robot is of this URDF. It also uh, contains all of the configurations for the robots. And this is the launch file that is launched while you build and run the Docker Compose file. This is the controller that takes inputs from your mobile and then gives accordingly correct configurations for your robot to move to that position or rotate your robot or grip something. Now these are the configurations of ROS2 control and gazebo that allows your robot to run and show you the video or any footage that you would want. And next, finally, the Flask server takes this video from your ROS2 package or ROS2 environment in Docker, and then this is the template, and it generates video streams in 5 different ports, and that is what you subscribe to in your Liquid Galaxy rig. So this, you can see there are frames here, and each of these frames uh, will be the videos that will run, and this is where we generate each page how we like it, and then we create according routes, and we handle zoom, we handle logo overlay, and this is how it also handles ROS by nodes, and these nodes are then run up and the video is streamed. So you can see in the output, you will see video streams are running on port this and this, and we will also see the control server running on the port this. The control server actually takes in the zooming and the logo switching commands from your mobile, and then outputs following results in the Liquid Galaxy streams, as you can see. And this is how everything works. So to recap everything, first this choose robot bash script is run. This goes to the Docker Compose. This builds a Docker file, and the Docker file builds all these components that are listed in these packages and Flask servers. So now let's move to a demo. This system will act as the Liquid Galaxy system, and this is the server that I'm using. This will ensure that the simulation is running smooth with GPU acceleration, and this is the phone I'm using for the app. So right now what I will do is I will just start up the server first, and so on starting the server you get a option like this. You have to choose your robot, so I'm just going with the first one, the interactive one. You can see the image builds and starts streaming our video. So this Liquid Galaxy pseudo Liquid Galaxy rig that I have designed, I will just refresh all the screens to take the videos, and so as you can see the video is up now. And next, with this phone I can just, this is my IP address, you can also see it from here. If you scroll a bit you can see the IP address clearly. So this is my IP address. I'll just connect to it, and then I will just I can rotate it as I like, and maybe I can also change the position. So I want to move it up, down, up, forward, backward, everything I can do. And next I can also grip anything. So the gripper closes when you tap on grip, and you can just widen the grip when you tap on release. So that's how the first simulation runs. Now going to the second one, you can just stop this for now and then go to the second option. The second option is also similar, it is a demo. So let's go to the third option, and that is another robot that I'm about. So another simulation opens here, and I'll just go and tap on reload in each of it, and you see the robot is up on the Liquid Galaxy. I'll just go on my app and change the option. So I want to go to the Amiga board right now. I'll just go ahead, I'll connect once again, and on connection I can just move my joystick like this, and it can travel wherever I want. The sideways is for the angular velocity, and up and down arrow is for the linear velocity. So about my experience in Google Summer of Code 2025 under the Liquid Galaxy project is that when I first started this project, I was completely new to the world of open source contributions. My passion for robotics wasn't finding a meaningful direction, but this project gave me exactly that. It not only deepened my interest in robotics, but also led me to learn and explore new technologies like Docker, Flask, Flutter, and for the first time I took responsibility to build an end-to-end product. These were the tools that I had no practical experience prior GSoC 2025, and this journey also led me to understand how important the open source contributions are, how collaborations, sharing, and community support makes any project impactful and long lasting. My mentors Victor, Moses, and Andrew have been incredibly supportive throughout. I am sure I will continue contributing to open source projects inside and outside of Liquid Galaxy from now on. And this has been my experience throughout Google Summer of Code 2025. Thank you for having me.
Hi everyone, my name is Victor Sanchez and I'm a Google developer expert in web technologies. One more year, I'm very proud to have been participating together with my friends at the Liquid Galaxy in Lleida in the Google Summer of Code. This year, as it almost happens every year, we have discovered that the Liquid Galaxy is not done, not at all. Every year we manage to find new use cases and new exciting applications that we can run on the Liquid Galaxy. In this case, this year, 2025, I've been working with Devanjan, a student that has been working on a robotic simulation for the Liquid Galaxy, working with gazebo and a simulation of a robotic arm. Now we are able to control that robotic arm with an Android application that will run on a tablet in front of the Liquid Galaxy, and you will be able to control that arm in many different axes, be able to interact with physical objects inside the space, grabbing something with the arm, moving it around. It is, I have to say, quite an interesting project. And it has come, of course, with plenty of new challenges for both the student, Devanjan, which has been absolutely great in these efforts, but also for mentors. You know, every year I manage to learn something from the students, something about the Liquid Galaxy, and something about the technologies we use that we didn't know in the past. In this case, we have been using a very extensive set of technologies, some new ones like gazebo, but not only. Also, we have been using Docker in a very kind of different way because it requires to have the GPU accelerated, and it's something that usually doesn't happen on the Liquid Galaxy, which runs applications directly. So again, plenty of challenges for the students, for the mentors as well, but we also managed to kind of squeeze every drop of interesting stuff to do in that Liquid Galaxy. One year more, I'm very proud of what Devanjan has been able to do, of the final applications that we are seeing today on the demo day. And one year more, I'm absolutely surprised by what can be done and absolutely eager to see what can be done next year. I hope to continue to participate. Good luck to everyone showing their projects today, and congratulations for finishing and making it to demo day. We know it's not easy. Have a good one. Bye bye.
Hello everyone, I am Alejandro Bernaldo de Quiroz Gómez. I am from Madrid, Spain, and I am currently studying computer engineering at Universidad Francisco Vitoria. I have finished successfully my second year of studies, and I am now going to start the third one. I'm here to present RoboStream. RoboStream is a project in which you take data from a robot and display it on the different screens from the Liquid Galaxy. This data is telemetry data and also cameras. Also, you can see the location in real time from the robot at the Liquid Galaxy. This project is based to see all the data that the robot gets on the Liquid Galaxy. Let's start with the login screens. Here we see a screen which asks for the server IP address. Then we have the next one, which asks for the robot IP address, and the last one, which asks for the Liquid Galaxy system information. For the first login screen, where the app asks for the IP address from the server, when you click on connect after input the for the server, for the first login screen where the app asks for the server IP address, once you have written it and click on connect, the app will fill the rest part of the IP, which is the port, which is 8000 by default. Then it saves the IP address locally using the Flutter library shared preferences and makes a connection check. This check is done by making a request to the main root of the server, and if the status code is correct, which is 200, then you pass to the next screen, which is the screen where you have to write the IP from the robot. For the Liquid Galaxy login screen, what it does is checks if there is any configuration preloaded, and if it exists, it automatically fills it, and then when you click on connect, it makes a post to the server to save the data on this file over here. And what it does next is the server tries to establish an SSH connection using Paramico, and also sends the logo. If the connection has been successfully, it sends the logo to the leftmost screen using this KML builder, which builds the KML for the logo. After all the login screens that we have, the app takes you to the home screen if everything is correct. You should see these three indicators over here: server, robot, and LG connection. Minimum will have to be in green, the server one, and the Liquid Galaxy connection for the app to work. We find here different cards that can be opened to show full data from the sensors and actuators from the robot. In the home screen, we find three indicators: Liquid Galaxy indicator, server connection indicator, and robot indicator. They work this way. The app makes this check connection, which is a request to the server. It makes requests, and if the status code is 200, means that it's connected. So it will maintain the indicator green. If this fails, the indicator will turn red. While the Liquid Galaxy connection indicator, which does is checks if there is any configuration for the Liquid Galaxy at the server. If it exists, it maintains a green indicator. If not, it will be red. And the robot one works exactly the same as the Liquid Galaxy. If the server turns red, all the other indicators turn red by default. The RGB camera telemetry card shows a big photo of the camera, which is an actual image that comes from the server. It has also a refresh button, which refreshes the image without cache, which means it's forced to refresh. And it also shows some simple data from the camera, some details. We have here in this server part the different methods that the app uses to get the camera data, the image data, and the image URL, because this image URL is needed to load the image in the app using image network, pointing to the endpoint from the server. For the other telemetry cards, for example, the GPS location, we have the different values, which are latitude, longitude, altitude, and speed. These values are taken from the server because the app subscribes to the different endpoints depending on the sensor that you want to see. We have also, in this specific card, two buttons to select the simulated zone. The locations can be Lleida and Pozuelo. You can choose, and you have here, for example, the get location, because it has to show which one is currently being simulated. And you can change it by setting another location. Here we have this class, which is called GPS data, which obtains the different values. We also have the RGB camera data. As you can see, we have also the IMU data, and all these classes from the different sensors take the values and parse them to the app. Now I'm going to show you how the streaming works in the app. When you click the streaming button, you see this menu, which you can choose from the RGB camera or see all the sensors that you can stream. You can stream several sensors at the same time, and once you are streaming, if you are streaming the GPS position, you have a button to start the orbit or to stop streaming for all the sensors. To start streaming, when you press the button, the first thing that the app does is to validate that the server connection is still established and that the Liquid Galaxy data is not empty, neither in the server or in the app. Then you can select between RGB camera or multiple sensors. If you choose RGB camera, it will just send a request to the show camera endpoint in the server. And if not, if you choose to show different sensors at the same time, you will be, a list will be displayed where you can select which sensors are you going to show. This list of sensors then will be sent to the server to show sensors, to the endpoint show sensors, where this data from the sensors will be built in a KML and sent to the Liquid Galaxy. Now let's take a look at the server. Here we have all the requirements that are needed for this server, which is Pillow, Paramico, WebSockets, Pydantic, Unicorn, and Fast API. We have the Docker file, which exposes the server on the port 8000 by default. We have the Docker Compose, which builds up the whole system. We have here a ROS folder, which contains the robot data, which is where the robot IP address will be stored. We have the simulated GPS, where we can find the GPS location from Pozuelo and Lleida for the simulations. We have the robot simulator, where we can find all the sensors and actuators that are being simulated using random data. We have the orbit builder, which builds the orbit around the location of the robot. We have the models, where we have for example, the IMU data, the GPS data, the RGB camera, the sensor data. We have the main.py, which contains all the endpoints from the server. We have also this logo images folder, which contains the logo that is being sent. And we have this Liquid Galaxy folder. This folder contains all the files needed to communicate with the Liquid Galaxy system. We have this slave calculator, which calculates which one is the leftmost screen and which is the rightmost screen to show the logo or the information. We have the LG service, which stores all the information from the Liquid Galaxy system. Also with the Liquid, it's based on this file, and this one sends the KMLs and manages the communication with the Liquid Galaxy. We have the KML builder, which builds the KML for the different sensors and actuators, also for the logos. And we have the balloon maker, which builds up the different balloons with all the sensors that are listed in the app.
Now I'm going to make a demo of my app on a real Liquid Galaxy. First, let's make a login. First, we need to enter the server IP address. We click on connect. This feature is not implemented. Why? Because we are going to implement all the robotics part in when we have ready the robot. So this will be the part to enter the robot IP address. Now the app works with simulated data. Then we write all the Liquid Galaxy details and we click on connect. As we can see, it has been connected. And now let's make a try. We click on the RGB camera and these images are being preloaded in the server and now are being shown in the app. And we can see if we click on start streaming and we click on RGB camera, we can see that on that screen we can see the camera from that is being streamed from the server. We have also the GPS position. We're going to select Lleida, GPS simulation zone established, and now let's stream it to the Liquid Galaxy. It will take us to that position, and we can see here a place mark with the Amiga robot, which is going to be changing while the GPS position is also changing. It changes every 5 seconds because it's being simulated at this moment. We can click also on start orbit, and it will start to orbit the zone where the Amiga robot is being displayed. If we click on stop orbit, it will stop. And let's try to stream more sensors. We can stream also the IMU sensors, the temperature, and we're going to do it at the same time as the GPS position. As you can see in the left part, we can see all the details that are being streamed from the robot to the server and then to the Liquid Galaxy. They all change every 5 seconds, and the robot is still on the main screen. The app has other options, configuration ones, which is the server settings, where we can put the change the server IP address if we need it. We have also the Liquid Galaxy setting part, where we can relaunch the Liquid Galaxy or clear all the KML and change the configuration if we need to. And then the robot part. This part will be to change the robot IP address when it's needed, because this project is planned to use a real Amiga robot that we have here, and we are planning to use it in a future. Thank you very much, and this is my project.
Now I'm going to talk about my personal experience in this year's GSoC 2025. And participating in Google Summer of Code 2025 has been a real challenge, and at the same time has been a very good opportunity for which I'm truly grateful. It has been challenging because I didn't know how to program in Flutter, and I just knew a little of Python. I didn't know how Docker worked, and I learned. So it was a great opportunity. I have learned a lot, and it has been very useful for me. Also, thanks to Andreu, I had the opportunity to visit the laboratories in Lleida, the Liquid Galaxy laboratories. And I would also especially like to thank my mentor, Moises Martinez, for guiding me very good and supporting me through the whole process. Overall, it has been unforgettable. It has been an unforgettable experience that has helped me grow as a developer and also as a person. Thank you very much.
Hello everyone, my name is Moises Martinez, and this year I have had the opportunity to be a mentor for the Liquid Galaxy project in Lleida, in Google Summer of Code once again. I have mentoring two students who integrated robotics and artificial intelligence with the aim of using Liquid Galaxy as a platform for remote robotic monitoring and control, enabling interaction with robots through audio, images, and data from the different robot sensors. Taking part as a mentor this year has been a truly rewarding experience. I have had the opportunity to support students in discovering how to design and develop a complex application that allows interaction with robots through the use of artificial intelligence techniques such as large language model, which are really famous right now, sensor function, and automatic planning. It has been inspiring to see and help the students discover new technologies, learn new skills, and realize how these technologies can be applied in a simple yet effective way. Then, if you have the opportunity, apply for Google Summer of Code.
Hey everyone, myself Anushka. I am from Gurugram, India, and I'm a second year BTech student pursuing my computer science and engineering with majors in artificial intelligence and machine learning from Dronacharya College of Engineering. And I'm a Google Summer of Code 2025 contributor with the organization Liquid Galaxy project. And this summers I was working on my project entitled GeoVision AI, AI-driven geospatial storytelling on Liquid Galaxy. Okay, so now we'll deep dive into the code and the architecture. Okay, so GeoVision AI is a web-based application that allows users to ask geography-related questions either by voice or by typing, which are answered by a Gemini AI model. The system identifies location, generates a story, and visualizes the response in Liquid Galaxy using KML balloons, camera fly to, and the orbit animations. Okay, so the features that I have implemented so far are speech to text and text to speech via Web Speech API, Gemini API integration via Google AI Studio, story generation from AI response, location extraction from the Gemini output, OpenCage API for geocoding, dynamically changing balloon with the generation of KML, Liquid Galaxy camera fly to using the extracted coordinates. There's a manual query input and a voice query input as well. AI voice narration for the generated story using the web speed synthesis. There is a start and stop orbit around the extracted coordinates function as well. There's an AI generated images in the KML balloons, and the fallback images will be shown as default. Okay, so the local storage settings for the API keys and the LG connection credentials, and there are modular web components using the vanilla web components. So the tech stack that I've used for the creation of my project, for the front end, I've used HTML, CSS, JavaScript, and web components. For the UI library, I have Material 3 via Material Web Components. The AI model is the Google Gemini 1.5 Flash via Google AI Studio. And for the APIs, like I mentioned, I have OpenCage and the FreeSound API. Okay, so now let's have a look at the code. So I have a couple of MJS files, modular JavaScript files, and this is the first one, that is the balloon.mjs. Here basically I have two main functions, that are clean balloon and the show balloon, for showing and cleaning of the dynamically changing KML balloons. This is a check connection function for checking the connections with the LG. This is a clean KML function for cleaning the KMLs. This is the connect to LG. This is the fly to view. So what it does is basically it flies to a particular location that is being extracted out of the Gemini response. It takes some parameters that are latitude, longitude, zoom, tilt, and bearing. The next one here is logo.mjs. So here basically again I have two functions. They are clean logo and the show logo for basically a clear view to the user. They can clean the logo. They can again click on the show button, show logo button to show it again. Okay, so this is the orbit.mjs for starting the orbit at a particular location. So here I have functions like build orbit, start orbit, clean orbit, stop orbit. So what happens here is first we stop any existing orbit, then we clean the orbit, then we build a new one, and then we start a new orbit. So there are functions related to it. Yeah, stop orbit, clean orbit, build orbit, start orbit. This is the reboot.mjs for rebooting the LG system. This one's for relaunching. This is a send KML function where I'm sending the KML to a slave. And this is the show logo. So I basically have my logo hosted in a public repo, so it becomes easier for the LG system to fetch it. This is for shutting down the system. Okay, so here comes the main tabs in my UI. They are being handled out from here. So this is the about tab. What happens here is a simple HTML CSS thing. So yeah, it contains how to use my app, how to get the API keys for the users who are new. It also has some queries, pre-mentioned queries for someone who's new to my application. They can just click on these query buttons and they can directly get their answers visualized onto the LG. Okay, so this is my home.mjs. So this is the home tab. This is the HTML CSS thing. Okay, so basically I have a couple of buttons on my home tab. They are I have a question button. So someone has a question which they have to ask to the Gemini. They can click on that button and then they are directly directed towards the Gemini tab. Then I have a couple of sample queries out there mentioned. So these are the functions. They are actually handling the sample queries. The first one is what is the capital of USA. Next one is tell me something about rising sea levels in Maldives. The third one is tell me something about Barcelona. And then I have a more sample queries button for the users who want more sample queries to test out. So they can just click on this button and then they will be directed towards this tab where there are a couple of more questions. The moment the user clicks on them, the answer gets visualized onto the LG. Yeah, nothing much. This contains the queries. They are changing for the Gemini. Yeah, there are 10 queries, 10 more. This is the save API keys. So basically I want the users to enter 3 API keys, the Gemini, Freesound and the OpenCage API into my application for it to work seamlessly. So they can enter it out here and they are saved in the local storage and they are, yeah, it's local storage dot set item and then local storage dot get item. Okay, so this is the settings tab where I have a couple of more credentials that the user has to fill to set up the connection between the application and the LG system. So that is handled from here. Here I also have a scan QR button. The moment the user clicks on the scan QR button, they are directed towards the scanning thing and they are supposed to scan the QR of the LG server and the URL is directly pasted into the field out there. So that's for the QR thing. Okay, so this is the tools tab, the switch case thing that I've added out here for cleaning the logo, showing the logo, clean KML, relaunch, reboot and shutdown. Okay, so this is the main file in my application. So what I have here is a connected callback function. Here I have the text to speech thing mentioned and I have add event listeners for the start orbit and the stop orbit. They check if it is not a number. If it is, they return invalid. Okay, so this is for starting the orbit. Stopping the orbit, I have an add event listener. So yeah, I have text to speech also for speaking out the AI generated story. Okay, so this is the function where I'm getting the coordinates from the location. I'm having an OpenCage API endpoint where I am sending the query and then I'm getting the location's coordinates from the OpenCage API. So this is the process query function. Here I basically have two types of queries in my application. Ones are the direct query locations. For example, if the user says take me to Tokyo, so this is treated as a direct query. And if someone says what is the capital of Japan, so that would be treated as a query for the Gemini. And they are being handled differently in an if else block. Okay, so what it does, it gets the location from the OpenCage API. It performs a fly to and there's an image that is being fetched from a GitHub repo, public GitHub repo, and this is the fallback image if there's no matching key value pairs found, so it returns a fallback image. So then there's a balloon KML function that I have is this. So yeah, then I send the balloon to the LG. Then I have an else block here. This is for the Gemini queries and I have an Google API endpoint, Gemini 1.5 Flash that I mentioned. And okay, there are this. And okay, so here I have some predefined latitude longitude positions for certain locations that may not be able to that the OpenCage API may not be able to find it out on its own. So yeah, it performs a fly to, sends the balloon and then it appears there. This is the generate URL from text that I mentioned. I have it here in my repo, public repo. These are the key value pairs that I have tested and mapped it to. This is the fallback image. This is the generate balloon KML function. So it takes coordinates, name, the Gemini text response. Image URL is for the Gemini and the image URL 1 is for the direct query locations. So I left it on this function to decide which one it got and to present it onto the LG. This is the KML. Here comes the send balloon to LG. This is for the Gemini queries, and then I have sent direct balloon to LG for the direct queries. Then here is the playing sound. Okay, so if it encounters any word like ocean, sea, wave, beach, so it's going to play the ocean sound, and if it encounters any word like fire, burning, flame, it's going to play the fire sound. So yeah, that was the voice.mjs. Then I have a QR scanner. Okay, so this is the index.html. I have used Material Web 3 like I mentioned. So yeah, that's all about my code. Now I'll show you how my app actually works. Okay, so this is the UI of my application. This is the home tab. This is the Gemini tab. This is the tools tab, the settings tab, and the about tab. Okay. So these are some sample queries. I can click on any one of them. For example, this.
Barcelona is a vibrant coastal city in Spain, renowned for its stunning architecture by Antoni Gaudí, including the Sagrada Familia. It boasts a rich culture, delicious cuisine, and a lively atmosphere.
Okay, so that's Barcelona, and if I click on start orbit, the orbit starts, and if I click on stop orbit, the orbit stops. So like I mentioned, I have some more sample queries, so I can click on any one of them, maybe this one.
Tokyo.
Okay, so I can ask a question as well. What is the capital of India?
The capital of India is New Delhi.
So it performs a flight to New Delhi. The balloon updates. And yes, that's New Delhi. I can also do a clean KML here that will erase the balloon. Yeah. Okay, so this will be settings tab to enter the credentials for the LG connection. This one's for the API keys. The moment we click on save API keys, it's API keys saved successfully. So yeah, that was all about my app. Now I'll talk a bit about my GSoC experience. This year I got a chance to be a part of Google Summer of Code 2025 and contribute to the organization Liquid Galaxy project. And honestly, it has been the most exciting experiences I've ever had. When I started, I just had the idea in my head about combining AI and Liquid Galaxy for an immersive storytelling experience for the users. Over the weeks, I got to work with amazing mentors from around the world, share ideas, and slowly watch this little idea turn into something real. The journey wasn't always easy. There were moments when I felt stuck and things wouldn't work out. But those moments taught me patience, problem solving, and how to keep going even when things are frustrating. My mentors, Claudia and Yash, were incredibly supportive. They just didn't guide me technically, but they encouraged me whenever I doubted myself and celebrated every small win with me. And I also want to give a special thanks to our admin Andrew for giving me this opportunity to be a part of this program. Without his trust and guidance, I wouldn't had this amazing platform to learn and grow. The best part, seeing everything finally come together. That moment when I could actually see and interact with the application I had been imagining for so long. It felt incredible. GSoC wasn't always just about completing a project. It was about discovering my own potential. It taught me to believe in myself and keep going when things got tough, and it also taught me that with enough passion and persistence, anything is possible. And most importantly, it has inspired me to stay connected, keep contributing, and grow as a part of this wonderful community in the coming years ahead. Thank you.
Hello everyone, my name is Claudia and I've been a mentor this year for the Google Summer of Code at the Liquid Galaxy project. I've been part of this community for several years, first as a contributor and now as a mentor. And every year I'm amazed by the creativity and dedication of our contributors. This summer, I had the pleasure of mentoring Anishka of her project GeoVision AI, a web-based application that lets users ask geographical related questions either by typing or speaking and get answers powered by the Gemini AI model. The system that then identifies locations, generates a story, and visualizes everything beautifully in Liquid Galaxy with KML balloons, camera movements, orbit, AI-generated images, and even AI voice narration. Anishka implemented an impressive range of features, from speech to text and joy coding to modular web components, showing both technical skills and creativity. She did a really great job and I want to congratulate her for the amazing work she have done.
Hey Liquid Galaxy community, this is Mentor Yash. I have been mentoring Anishka for this Google Summer of Code as a secondary mentor next to Claudia, and I am happy that we have one web project finally over the Liquid Galaxy, very similar to how we have many Flutter projects and app projects on Android. So I'm really happy over the future of web and how that space would be over the years transformed, and I'm really happy for the excellent foundation that the LG Web as well as his application for the LG AI visualizer has been going. So these are some of the things where we have to take a step back, look at the whole thing and see that yeah, these are some of the exciting challenges that the Liquid Galaxy is doing. We are now doing web, and I'm really happy for her GeoVision application, and I'm looking forward to it having the best user experience on the web. So yeah, those are the two contributors, and I am really happy for them, and I'm hoping them that they get a very successful GSoC. So yeah, thank you everyone. See ya.
The capital of the USA is Washington, D.C. Barcelona is a vibrant coastal city in Spain, renowned for its stunning architecture by Antoni Gaudí, including the Sagrada Familia. It boasts a rich culture, delicious cuisine, and a lively atmosphere. You're now viewing Pacific Ocean. You're now viewing Mount Everest.
Hi everyone, my name is Sanya Singh and I am pursuing AI ML Artificial Engineering in BTech in Bangalore, India. I am a second year student and my organization name is Liquid Galaxy and my project name is Catastrophe Visualizer. So before we begin into let's begin into the project and let's go through the code base, understanding what the project is all about. So the purpose of my project is we take APIs from USGS and different sources, and then we visualize the disaster on the Liquid Galaxy to help us understand the severity, time frame the disasters has been taken place, and to keep updated in a simpler form. So let's look into the code base. So our project's architecture somewhere looks like this. So it contains of the helpers, that is LG connection, share preference, and different types of models like SSH model, disaster model, earthquake model, the KML basic model of how and what things will be visible. And then we have the providers, for example the SSH provider, and then we have screens, the different kind of screens that are seen, and then we have different services like the API, LG, KML services, and then last we have the main.dart. So here I have opened the main.dart. This is the my app. Here you can see that we are using different providers. So the purpose of the provider is for the state management for real-time data, and here you can see that we are using for the disaster API service, and also we are using the providers for the liquid SSH service working together. And here you can see that there is our app name in this, and we also have a professional theme, like we have here dark theme and different colors for that. If we move down here, we also have the code for custom splash screen to be creating that. Moving on to next, this is the API service file. Here you can see that we are getting the data from the US GS government website. So from here we are getting the earthquake data. Here you can also see that we are using notify listeners that updates the UI automatically, and here you can see how well we are also doing the graceful error handling, so that if there is error handling, and also we are taking the user feedback. The whole purpose of this is to convert the raw API into the dot objects. This is the LG service file. Here we are using dart SSH2 package, and here we are taking four things: the host, username, the password, the port, and the recount details here. Here we are getting the details from the shared preferences file. Here, this is the shared preference file. From here, we are setting it, and afterwards we are getting it in our LG service file, all these details, and then we are storing it here. After that, there is a function here. We are first, creating a SSH socket, and after that we are making a function, and which is properly doing the authentication. And if the authentication is passed by the notify listeners, like if it updates the connection statement through notify listeners, and then we will, if it returns null, then it is a success, or else it throws an exception that authentication is failed. And that's what we get. So here we get direct connection to LG master rig. When we come down, this is the code for uploading the KML file to the Liquid Galaxy. So it makes sure that it create directories and set permissions, and all those things, and it distributes the content across all the LG clusters, and it all automatically syncs to all the LGs. And also here when we moved out, so here I was talking about that it creates the directories and sets the permission. And also here to get the screen count, here we have a universal way to find out the screen count. It is done automatic, it is not hard coded. So this is the simple main screen. Here above we have given the number of filter options. So here we have given how our filter options are gonna be displayed, and here the different types of tabs that's gonna be there. And later down when we come, we have different build options. Here we are particularly looking for building the disaster card. So this is a function of how disaster card is built, the format, the date format, and when we press it, whenever we clicked it, it sends all the disaster information to the LG, and this is how the card will be displayed. The tooltip button, or whatever we get, is the send to LG, and it does on the tab. Here we have the send disaster to LG function, which we discussed before. This is the KML. Here we have written the disaster alert, what is the title, and the details related to the disaster, the date format, and the place, and all the longitude and latitude information related to the disasters is written here. And here we have upload file, so that this disaster and the ID will be uploaded. So this is the generate KML file. Here this part of the code is responsible for writing KML content in the file, to write the KML content. This gives us a directory for saving our files, and sometimes if there is no other place, it creates a KML folder in external storage to store save the files, and this is for a fallback to the document directory if there are any faults. And if there is an error, here we also have a catch matter that directly stores at the temporary directory if there is any faults. Last, I wanted to show you the SSH model. So this is the SSH model, which consists of host, port, username, password key, and screen amount. And this is the disaster model. This is the disaster model with a string ID, type, latitude, longitude, time step, severity, and place. And this is the KML, basic KML model format of how the KML will be looking. This is the disaster visualizer app. Here we can see the total number of disasters. We can see the extreme and the timeline. Here we have a filter option. For example, these are all the. Now let's only look for the moderate option. So now we got in the 7 days timeline the moderate options. Let's look for in the last 3 days. So now this has given us all the moderate in the last 3 days. And when we click on this, we get a disaster card saying the type, magnitude, severity, location, time, and the place. This is the connect page, and this is the about page. Here it has our logo, and it also has features listed of whatever features we have, like it takes earthquake data from UGS, it has filtering options, and it has interactive KML, and also it has the technical information used here and the connection and about the live updates. Now let's connect this to Liquid Galaxy and see. Here you can see the Liquid Galaxy on the 3 screens. Now we have added all our details. Now we are going to connect it to the LG. Here you have seen that it is connected to our IP, and here you also can see it is connected, and here we can also see our logo being displayed. It's been great working in GSoC. It is one of the times I have learned a lot. For the first time I learned what Dart and Flutter for this project. GSoC in itself is a huge experience. It gives you the exposure to directly commit to the organization and then do something in the open source, which is overwhelming at first to talk about or even think about. It's still overwhelming how you can do things, but when you take one step at a time, you can slowly get closer to it and you can be able to achieve things. And yeah, GSoC has also taught me a lot of patience, because there's so many times things goes wrong and it doesn't work, so you gotta be patient, try again, and then make sure that it works. And you should also always be in concentrating, and it has made me learn about new skills, new exposure, and it has also given me a different kind of way I view things, people view me, and a lot of confidence, which has helped me in my college, in my life in general. So GSoC has been a great opportunity and I'm very glad to be a part of it.
Hello everyone, my name is Mahinur Sarki and I have been mentoring Sania's project, which is a Catastrophe visualizer. I was a Liquid Galaxy contributor for 2 years in a row, and I thought that the best way to give back to the community was to mentor and to be able to help contributors and guide them towards success. The idea of the Catastrophe Visualizer project was to display real-time information about natural disasters such as earthquakes and hurricanes via open APIs and visualize those data on Liquid Galaxy rigs. My experience as a mentor was sometimes challenging. Of course, life happens, and especially to students, and we all know that unexpected things can happen which can delay progress. So because of this and some of the communication and consistency issues, some of the deliverables were not achieved on time. However, regarding all this, my experience as a mentor was very valuable to me because I gained experience and I was able to grow more as a leader. I was able to develop more problem solving skills. I was able to gain more perspective on how to help contributors and how to manage expectation and of course how to adapt when things or projects don't go as planned. And even with all the challenges, I'm glad that I have been able to be part of this and mentor this year with Liquid Galaxy. And I'm looking forward to always giving back to the community and always being part of its growth.